Good morning, everyone. Good morning, colleagues, friends, and everyone that has joined the webinar. I would like to welcome everyone. And just to start off, we do understand that the COVID-19 and all these factors that have been affecting us as part of the pandemic have come with various challenges. However, they've also come with various other opportunities for us to do things differently. And this webinar is titled Towards Modernized Silviculture. And we are quite excited that we got a good response of over 300 participants who RSVP'd for this event. And basically our audience is diverse. A majority of our audience is from various countries, a majority from South Africa, but we have representation from African countries such as Zimbabwe, Botswana, and various other ones. And we also have participants from Brazil, as well as Sweden and Finland, and various other countries. And basically looking at occupations of where our participants are involved, we have a lot of foresters, silviculture specialists, academics, researchers, consultants, and our students, machine manufacturers, and various other occupations. So to this webinar, I just want to say welcome. Our hope is that this webinar will be able to be an important part wherein we can learn from each other, as well as exchange information and build relationships as well as connections. Thank you to our presenters, and thank you to everyone that will be participating in this program. This is the first webinar of this nature, and we hope that we are able to host something like this again next year. But without further ado, let us go into the program. I would like to introduce to you Dr. Mawila, who is our campus principal, and she has been very supportive of this initiative from when it began, and she will be then doing the opening as well as the welcome. Dr. Mawila, I will hand over to you. Unmute.
Colleagues, good morning to those of you that it is morning, and afternoon for those of you that it is evening to those of you that it is evening. I am very pleased to welcome all of you to participate in this webinar hosted by the Nelson Mandela University and specifically the George campus. It is with great pride that we are able to, even under these circumstances, welcome guests from all over the world thanks to technology. And thank you to Muedanyi Ramantswana and the colleagues at the University Nelson Mandela for putting this great opportunity together to have scholars engage and engage on issues of modernization in silviculture. And it's a very important topic given that from time to time, we are forced by even natural circumstances to reflect on the sustainability of our resources, the sustainability of our livelihoods. Silviculture as well as forestry are one of those critical aspects of our lives as the global community that sustain and support us, but also that are under threat and need to be continually engaged on. It is with great pride that the university is enabling this opportunity for connection beyond our borders in the continent of Africa, but also with the global south. I am very pleased, colleagues, that we can continue to have a conversation on scholarship as well as enabling our critical resource management strategies in the country as well as in the continent. And I encourage all of you to have the most robust conversations, and I know that our team of experts at the UNM will fly the flag high. We do support sustainability, but we also want to be able to contribute to the resource management strategies that are aligned also with the National Development Plan in South Africa, with Vision 2030 for the Sustainable Development Plans, and we are very proud to host this. I shall be attending and listening, colleagues, and I hope to learn as much as is possible within this context. Welcome, and do have great engagement. Thank you.
Thank you, Dr. Mawila, for that welcome, and just for just setting the tone for the rest of the webinar. So I'm just going to share the program with the list of the presentations of what we are going to be able to see in terms of our lineup. The program comprises of about 7 presentations that we are going to focus on. But as I just begin, as an introduction, in terms of South Africa, we have seen various developments as well as changes over the past decade in silviculture. And not only in the way we do things, but also in the technologies that we have. We have seen the introduction and adoption of new machines as well as technologies by various stakeholders, from nurseries, soil preparation, planting, as well as weeding and pruning. These developments have mainly been driven by various reasons, such as the need to improve ergonomics, the need to increase productivity and reduce costs, the need to improve planting quality and ensure that survival, growth, and uniformity are consistent. However, even though silviculture technology has lagged behind for a number of years if we compare to harvesting, we have seen a growing interest from both locally and internationally in terms of innovation and development in this field. So today we are going to listen to 7 presentations from different presenters who have voluntarily agreed to share their knowledge, and their presentations will focus on developments in terms of nurseries, digital technology, as well as realistic perspectives from a contractor as well as a grower company on the processes involved in modernizing silviculture. And lastly, for us to remain abreast with what is happening internationally, we will have a presentation by a presenter from Brazil, Professor Saulo Guerra, who is going to be able to present and give us an update about what is happening in Brazil. So please note, we have a Q&A section which you can use to be able to post your questions. We will have our question and answer session comprehensively at the end. So if you have questions, just indicate who they are dedicated to, so that it can make it easier for us to facilitate the process at the end. Each presentation is 15 minutes, so the presenters will comprehensively cover their content within that given time. And just lastly, as a point for you to take note of, is I have attended a number of webinars, conferences, as well as presenting class over the past couple of months. And yes, it is inevitable. Sometimes you might find glitches. So please bear with us as we work through those small issues if they do occur. The webinar will be recorded and you can request a link that we will be able to share once the webinar is concluded so that you can be able to refer to it. So without wasting any further time, I am now going to move on to our first presentation. And our first presentation will be from Sean Biggs, who is from Eliport. And the title of his presentation is Paper-Based Pots as a Solution for Improved Mechanized Planting. Just briefly about Sean. Sean is a director at Eliport South Africa. And having grown up in a nursery, it was logical that he would follow his father's footsteps. After completing his BSc in horticulture, agriculture economics, he joined Sutherland Seedlings in 2006. After 10 years of growing Sutherland Seedlings, Sean started Eliport South Africa to meet the growing demand for new propagation systems. This has allowed Sean to visit some of the leading nurseries around the globe and in South Africa. Sean is passionate about the future of horticulture in South Africa and what technologies are likely to be adopted in the next decade. When growing plants or visiting nurseries, When not growing plants or visiting nurseries, Sean is an avid kayaker, cyclist, and trail runner. Sean's proudest sporting moments are medaling at the World Canoe Marathon Champs in France in 2006 and completing a 1,500-kilometer kayak expedition in Peru on the Amazon River in 2004. Sean is married to Shale with 3 young daughters, Sage, Misty, and Amber, and currently resides in East London. I hand you over to Sean. Welcome, and we look forward to your presentation.
Thank you very much, Muedanyi. It's an honor to present today, and welcome to the attendees. It really is a fantastic initiative, this, and great to be part of it. Thanks for the introduction there. Yeah, my name is Sean Biggs from Elipot, South Africa, and my presentation today will be on paper pots as a solution for improved mechanized planting. Right, first up, very briefly, what is Elipot? Who is Elipot? We have an integrated propagation system comprising of machines, paper and trays, and to manufacture the paper pots, and then we supply backup service to that solution. Elipot was first founded in 1993 in Denmark, so the head office is there in Esbjerg, and we exclusively focused on the Elipot system and adding value to our clients. We do feel we're a market leader in the paper pot space, and we have quite a global presence. As I said, the head office is in Denmark, and we have a number of sales offices, 16 distribution partners, and we're present in over 120 countries. So we do have a real global presence and working in both forestry as well as vegetable, fruits and ornamental sectors. Right, what are the key questions today and with my presentation? I just wanted to start with first, what are the key challenges with the current planting system? The standard in South Africa is the 128 Unigrow tray with inserts. In South America, they call it the tubettes. And there are a number of challenges with the system. First up is the plant supply to the compartment with a machine. Plant supply logistics to the field can be difficult. The trays are quite bulky to transport from the nursery to the holding nursery or to the field, and also very difficult to handle in the field. You tend to find being a flexible tray and with the inserts, the inserts can fall out, and so you find it's quite a difficult system to handle in the field, and that obviously reduces efficiency. Extracting plants from the trays is a huge job and very time consuming and difficult to automate. The extraction of plants from the inserts also can lead to root damage. So root damage during extraction and when planted is a challenge. And then linked to that is the quality of establishment. That root damage and that logistics chain can lead to transplant shock, which in turn can affect how the plant takes off, can lead to mortalities and wind throw down the line. So there clearly are a number of challenges with the current planting system, and that presents us with opportunities to improve how we do things. Right, what is driving the change to mechanized planting? First up, I've listed increased cost and availability of manual labor. As we know, over the past few years, the cost of labor has increased significantly, and availability is also a challenge. Mainly in terms of absenteeism in the South African context. The other consideration is safety concerns and ergonomics. So with safety, I think there's a real focus on providing a safe working environment for our staff in the forestry sector, and ergonomics. You know, the working the compartment is a difficult job. It's often in difficult terrain, and it's backbreaking work, you know, bending over and planting. So there really is an incentive to look at mechanization from that point of view. Planting efficiency, machines give the opportunity to plant quicker and plant better. The quality and speed of planting should be better with machines. And then finally, the cost of plant material is certainly increasing as we move from seedlings to clonal material. So that cost is increasing, and often when we introduce new clonal clones, then the availability of those clones is limited. So there's a real benefit, or should I say, incentive to establish those plants as well as possible. What plant specifications does effective mechanized planting require? The bulk of my talk today is going to be on root quality and root integrity. I think that is absolutely critical with these machines. But also uniform plant height and branching is important. A uniform root collar diameter and sturdiness ratio is very important as well. Some of the machines grip the stem of the plants, and therefore you need a decent RCD. And then finally, as with manual planting, good plant health is critical. So why are paper pots better? The first point I'd like to cover is the fact that paper pots are a stabilized substrate. What does that mean? It's a growing media that holds its shape or form without the aid of the roots. So with the Unigrow system, the roots needed to hold all of that medium and everything together. With a stabilized substrate, that's not necessary. So the paper pots in our manufacturing process, the medium is sucked via vacuum into a chamber and is condensed and is encapsulated with paper, and that paper holds the medium together. So that has a huge benefit both in the nursery and the field, because you can start handling it almost immediately. I'd just like to touch on the nursery side of that. It allows us to do quite a few automated nursery tasks, such as automatic placing of cuttings or sticking, transplanting, sorting, selection. I've got a quick video here of one of our partners, TTA. They have a machine here which does automatic sorting in the nursery. So as you can see here, there's some cameras in the forefront, and what this is doing is it's sizing the germinated forestry plants in Scandinavia. It's sizing those and into 3 different categories. The cameras take pictures, videos, and they'll analyze the shoot growth and analyze the root growth and discard any that aren't up to the quality spec. So these machines are really transforming how we work as nurseries, and I think we'll see a lot more of these in South Africa as well in future. Another reason is the root aeration status. To maintain that root integrity, you need a healthy root system. And first up, oxygen supply to the roots. Roots need oxygen to develop well, and with the paper pots you have this microclimate around the paper pot. There's an airspace between the paper pot and the tray, and as you can see in the figure in the bottom there, we get great airflow in our trays past the paper pot, and so the full circumference or full surface area of that container is allowing air movement between it, and so you have healthy roots and a well consolidated plug. This is just an illustration of the drying down patterns of different containers. So at the top there, you've got what would be a Unigrow container, and you can see quite often that bottom of the plug stays quite wet and can actually be anaerobic. Whereas especially if you look at the bottom at the drying down pattern of a paper pot, you're sucking in air from all sides, and that promotes good root development. Air pruning is absolutely critical, and that's something to take away from this presentation today. So what is air pruning? Air pruning is the drying off of root tips that are exposed to the air. And what are the benefits of that? So what really happens is as the root grows through the paper pot paper, then it's dried off. And just like when you break apical dominants, when you cut the tip off of a growing shoot, you get branching beneath that. The same thing happens in the paper pot. So you get this root initiation and the secondary root formation behind that. So first up, you get a root with a better root architecture. As it's dried off that root, you might have a lateral root, which is like a stabilizer root for the tree. And as it's dried off, it's like pressing pause. And as soon as that paper pot is put into the soil, into the pit, that root will carry on growing in the exact same direction that originally intended to. As opposed to a Unigrow system plastic container where that lateral root will hit the sidewall of the plastic container and be turned downwards, and in a worst case scenario you might get some root spiraling and it becomes root bound. So the big benefits is you have a lot more secondary roots and you have a much better root architecture, which obviously is a benefit. This video I really like. It's a larger volume elipot. It's actually a fruit tree, and we have taken the paper off here and we're just showing all those secondary roots that have developed there and how they're holding the medium together. So it really concentrates plant energy on the roots and not the shoot growth, so you can have a better leaf to root ratio. You have higher roots up in the container, so you have better container utilization. You really have a large quantity of active young roots that quickly capture the pit. Typically, a nursery will see a 20% gain in the root collar diameter, and out in the field up to 300% more secondary roots. So really the message here is that air pruning maintains the root integrity. That plant can be thrown on the ground and it's still, that root system is still going to be intact, and that really has benefits when it comes to establishing out in the field. The third point I wanted to cover was density. With that manufacturing process I described earlier, the paper pots have a higher density or weight than standard loose fill plug. So this means they're easier to handle. Some of the mechanized planters have a gravity feed system into the head, and that extra weight really helps that feed that plant down the chute, and it's less likely to get clogged up. And the same principle applies to planting tubes. A comment has been made that especially with the unigrows, when they dry, they become exceptionally light, and you'll drop them down those tubes, and if you puddle planting with, say, super absorbent or something, it actually doesn't penetrate that slurry. Whereas with this extra weight, you get that penetration and better establishment. Water on capacity. The higher density provides a higher water in capacity. This obviously means less water stress, less transplant shock, and this is important because with the mechanized planters, as they get quicker, so the companies are needing to keep what they call more inventory next to the machine. You know, you don't want downtime on these machines, and so as you keep more inventory, so those plants are sitting out in the compartment exposed to lower humidities, higher radiation for longer, and so this water on capacity really does help there. And then once established, a higher water on capacity means it has a great affinity for water, so when you transplant into that pit, you're not going to get water being drawn out of the paper pot, and it improves your establishment. So what are the outcomes? Well, first up, and obviously less mechanical damage at planting. That extraction from the tubes, it's been said that can cause mortalities as high as 10%. So this is a big gain there. And then less damage in the machines. So plants can get clogged up or tangled in the feeder tubes of the machines, and this is less likely to happen with paper pots. Another big benefit is that quite often nurseries are waiting for the root system to develop in the nursery, and that they end up sending a taller plant than they would like, or that a mechanical planter would like. But because of the quicker root development in the nursery, and because it's a stabilized media, you can send out that root system, you can have full confidence will perform well out in the field. So you can send out a shorter plant if that's what the mechanical planter requires. And then finally, it's less predisposed to J-rooting. If you look at a standard sort of plug shape from an insert, it's got a tapered point, which is very easily J-rooted. With your paper pots, a cylindrical shape, a little bit more difficult to J-root. In terms of efficiency gains, easier handling on the roadside unpacking team, as there's no extraction of inserts. The gain there is approximately 2 hours per hectare, so there is a potential to reduce the size of the roadside team. And then depending on how you dispatch, if you dispatch in Swiss rolls or what they call rocambolies in South America, then certainly there's no inserts, no trays to go back to the nursery. That has a huge efficiency gain. And so there's less chance of introducing diseases to the nursery from those trays that are being taken back to the nursery. What are the yield gains out in the field? So growth differences observed range from no difference when conditions are absolutely ideal, right up to 30% biomass gain on harsh sites. With survival gain ranges from 5 to 8%, depending again on the site and the planting conditions. This graph on the right is from one of our international clients. You can see in the blue column how many hectares were planted in this trial, and then the green column the percentage survival after 2 weeks. And you can see with paper pots 99.5%, whereas with inserts 94%. So that's quite a significant gain in survival, and then this is probably likely to be amplified by mechanized planting. So what the message is that in adverse conditions, paper pots outperform standard inserts, and this has a huge benefit to mechanized planting, because with these machines the investment is substantial, and what we're finding in South Africa now is that often our rains are coming quite late, And so often we're only able to start planting in November, and then Christmas is upon us, and so you've got this reduced planting window, and which is problematic for these mechanized for these planters. So with paper pots, you can now plant more in the shoulder season, so you can plant more in spring, more in autumn, extend your planting window with obvious benefits in terms of reducing fixed costs on these machines. Just again on the yield gain, this is just a study that was done in Brazil a number of years ago, and really what I want to point out here, this is one year after transplanting eucalyptus, and you can look at the root volume down the bottom there where paper pots were more than double. Right, and then future considerations. I just want to give some thought to where to from now with paper pots and mechanized planting. First up, something that needs to be focused in on is plant quality index. Everything in our logistics supply chain, everything in terms of our PQR standards at the nursery is developed for manual planting, and there's definitely a need to focus on what's needed for mechanized planting, because that is coming in terms of our standards to most efficiently plant those plants out in the field with mechanized planting. There could even be breeding selection based on mechanized planting in future. In terms of plant supply logistics, there's a big debate in the industry at the moment on dispatch. So some nurseries are dispatching in trays, as we have done in the past, and others are dispatching in Swiss rolls, what they call rocambolis in South America. And there's pros and cons to both systems. And so that's something that we need to work through, and as an industry try and standardize as much as possible how we go about getting plants to the compartment. There could well be templates for planting machines. I think a challenge also from the mechanized planting point of view is that there are a lot of different trays out there. There might be 128s, there might be 98s, there's polystyrene trays, there's unigrows, there's plastic trays, and so there could be a call for a template for the planting machines, and how will we get those plants into those templates? So, you know, we could possibly see transplanters, like I showed earlier in the presentation, at the nursery, transferring those plants from the nursery tray into the template that the machine will use. Another big debate is around holding nurseries versus just-in-time delivery. Just-in-time delivery has some fantastic benefits in terms of establishing the plants in field, less transplant shock, but needs a lot of management in terms of your logistics. And so this is something that's been looked at, and I think would need to come in when we go the route of mechanized planting. And then another focus area needs to be the supply of the plants to the mechanized planting, not only to the holding nursery or to the compartment, but how do we get them to the actual machine? And you know, what we want to do is we want to minimize our footprint and our impact on the compartment, minimize machinery working there. And so what I see in future possibly is a drone supply situation where you have a drone base at roadside and ferrying plants to the mechanized planters to minimize that impact. But yeah, I hope I've given you some insight into paper pots and why they're a great solution for mechanized planting, and hopefully pose some questions to think about in future. Once again, I thank you, Muedanyi, for the invite to present today. Here are my details. If anyone would like to send an email or get in touch, please do so. I know there'll also be some questions at the end. Thank you very much.
Thank you very much, Sean, for that insightful presentation. And I think you have clearly explained the benefits of paper pots, and just given us some food for thought in terms of the important things that we need to take note of in terms of mechanized planting, and some of the sort of gap areas for the future that we need to focus on. Thank you for that. Now we are going to be moving on with our presentations, and our next speaker is going to be Jacob Zimbodza, and he is going to present on the effects of manual, motor manual, and mechanized pit preparation techniques on tree growth response and operational productivity. Just to give you a brief introduction on Jacob. Jacob is a qualified forester with 16 years experience in both harvesting and silviculture operations, with him being 7 years as a forester and basically managing a contractor in the KZN Midlands. He is currently a forestry manager at Siangoba Forestry Solutions in New Hanover. And Jacob has a diploma, BTech, and is currently pursuing his MSc in forestry. And what he's going to be presenting on is basically what his MSc is all about. So, Jacob, welcome, and we are looking forward to some of your findings in terms of the topic that you'll be presenting on. Let's remember to unmute.
Can you hear me now?
Yes.
Okay. Thank you so much, Muedanyi, for the introduction. Actually, Muedanyi is my supervisor for my master's, and basically today I'm going to be talking about pitting methods that you've got in the industry. Basically, it's going to be manual pitting, motor manual pitting, and fully mechanized pitting techniques, and how it affects operational productivity as well as a growth response. So briefly,
sorry, Jacob, if you can just maybe play the PowerPoint.
Okay, so briefly, that's the outline for my discussion. I'm going to start with the introduction, the research questions and objectives, methods and materials, results and discussion, and then the conclusion, as well as the references. So basically, what is site preparation? It all starts, because any establishment or establishment process, it starts with site preparation. And it's any form of treatment that you subject your land to in terms of vegetation management, in terms of residue management, as well as soil preparation before you do any planting operation. And within soil prep, it's in fact, soil prep is any form of tillage that you induce on any given piece of land to change the soil structure. And normally it takes the form of either intensive methods or moderate methods, of which 4 decades ago, the industry was working under the notion that intensive methods of soil preparation are of benefit in terms of yield. That's why you'd find that in the past you used to have a lot of plowing, a lot of trenching, a lot of disking. As you can see from my presentation here, there's plowing, there's trenching, there's disking, as well as subsoiling or ripping. So this was the in thing by then, because research had shown that intensive soil preparation methods, they tend to get or to benefit in terms of better yield. But however, subsequent research has shown that those moderate methods that were being neglected, they tend to give the same results as intensive methods. Hence, the industry embarked on moderate methods of soil preparation, and in particular, pitching being a preferred method in South Africa, since it gives us the same yield results. So, as you can see here, manual pitching has been like in existence since time immemorial, and that's the most common way of preparing our soil before you do planting. But in the last decade, we've seen a general interest in terms of the industry investing in motor manual methods of soil prep, as well as fully mechanized ways of preparing the soil. And those percentages that you see here, 56%, 10%, and 34%, what it simply represents, there was a research or a research that was done for a selected area, and these are the results that were obtained in that area, where 56% for that area, soil was being prepared manually, and then 10% it was motor manual, and then 34% it was fully mechanized pitching. So you can see there's a growing interest in terms of using fully mechanized equipment to prepare the soil before planting. And then these are what I can say, the major drivers of mechanized soil preparation in the industry. So far, I think Muedanyi has touched a bit on some of those factors. And these include economics, health and safety improvements, productivity improvements and cost reduction, pitch quality and consistency in improvements, as well as social challenges that you have got. And I think we all know the social challenges that you've got in South Africa, not just South Africa, but all over, in terms of labor availability, employee availability at work, chronic diseases. So all those things, they're tending to drive the industry into mechanized reestablishment. So my research was mainly based on this question as to what are the effects, what effect does pit preparation techniques and slash management have on pitch quality, survival, seedling survival, initial growth, and operational productivity, with the following objectives in mind. Because the thing is, what's happening at the moment with all this influx of equipment that you get coming into the industry, there isn't much information or publications in terms of what are the effects of these methods that are coming through, in terms of how it affects productivity, in terms of how it affects initial growth, as well as seedling survival and pitch quality. So that's what prompted me to embark onto this research. And basically my objectives were the following. Firstly, it was to determine the impact of manual, motor manual, and fully mechanized pitching on productivity, which is our pits per hectare, and as well as the pit density, which forms our pits per hectare at reestablishment. Because what I did, I picked up on the three common methods that are being used, which is the use of a pick, the use of motor manual equipment, as well as fully mechanized equipment. Then my second objective was to understand the effect of manual, motor manual, and fully mechanized pitching implements on pitch quality. And when you talk of pitch quality, the things that you look at is mainly the tilt, size of the pit, which is the dimensions, basically the width and the depth of the pit, as well as the pit volume. And then lastly, it was to determine the influence of slash management, which is either banning or spreading slash, on pitch quality, planting method, so the slash management, pitch quality, and planting method. And on slash management, it's either bent or you spread the slash, and on pitch quality is influenced by the pitching, as well as the planting method. And you do your planting. It's either you plant with water, or you don't use water, or some guys in the industry, they are using gel, for example. But in this case, I looked at water planting and how it influences on survival, as well as growth and uniformity. Okay, I'll go straight to the methods and materials that I use in order to collect the data. So on the first objective, on productivity, I did a time study, measurements, and what I did, I identified relevant elements, because each and every pitching process has got elements that are involved. So I had to time each and every element that was selected or that was relevant to each pitching method. And this, I recorded it on a Trimpo, which is a handheld computer, and I used it to capture the time that was taken to carry out each and every element for a given cycle. And then eventually also I did some measurements on the specimen just to see the accuracy, because your specimen eventually it gives you your pitch density, which is your pitch per hectare. Then the second objective was to determine the pitch quality. So I measured the dimensions of the pits, of all the pits after pitching, and as well as the pit volume, and the soil tilled. And this was based on a sample size of 10 pits per pitching method and slash management method. Then on the third objective, it involved setting up a trial to observe the growth patterns, and this trial was monitored for 12 months, with measurements being done from day 0. And the factors that were at play here, it was the slash, the pitching method, and the planting method. I think I mentioned this before. And then data analysis was based on descriptive statistics, which eventually gave me a guide as to how to do further data analysis. So I'm gonna go straight into my results. I'll start with productivity studies. So what you are seeing there is the sample size of from all the for the various pitching methods that were being observed, with the highest observations being in fully mechanized pitching. Those treatment codes that you see, MMB is the motor manual bend, then MMUB is motor manual and bend. So it's just the treatment on the different sites that we observed. So you can see here the sample size of 1,227 pits for fully mechanized pitching, and on fully mechanized pitching and bend, it was 929. Then followed by 628, and yeah. So basically, it's just the sample size that, or the number of observations that were made for each and every pitching method, of which a minimum sample size of 384 was the recommended one, according to, if you do your calculations statistically. So I think with a good sample size, we have a good representation of the data for analysis. And then briefly, what you see there is the work time distribution per second, because obviously, if you've got equipment in field, you need to know how much time is it taking you in order to give you a certain amount of production. So what you see there on the x-axis is just the time in seconds per pit taken, and on the y-axis is the pitching method versus slash management. So for example, manual pitching is at the greatest time on unbent areas, with almost like 32 seconds per pit taken. But if you look here, if you look at the black section here, it says move. So everywhere it says move, that's the time that was taken to move. So the greatest time for moving, you find that it's in manual pitching on unbent areas. And the least time you find it in fully mechanized pitching with less than 2, it's about 2 seconds to move per pit. So this is based on the total observations that were made and then divided by the total time that was used for observing. So what you can see here is that fully mechanized pitching on bent areas is much more productive than all these other methods, because it's sitting on less than 10 seconds per pit. And then motor manual pitching with the auger, it's sitting on about 13 seconds per pit. So generally, it just gives you an insight as to what to expect in terms of productivities from each method. Then the next slide you're seeing there is just an overview of the productivity statistics, just a summary. What it does is that on the x-axis is the treatments, which is the equipment that was used or the method of pitching, or on either bend or unbent sides. And then on the y-axis, there's productivity in terms of pits per hour. And here we can see it also gives us an insight in terms of variation of productivity, because the box and Wixter plots, what it does, if you look at the bottom end of the tail, for example, on motor manual pitching on bend, gives you the minimum value or the least value that was obtained during observations. Then on top there, you get your maximum value that was recorded during the observation. Then at the center is your mean. So for example, the mean for motor manual pitching on bent areas is just below, or you can say it's close to 400 pits per hour, compared to, for example, fully mechanized pitching on bent sites, which is 500, just above 500 pits per hour. And then you see inside the box, the size of the box and the distance from the tail to the box. It gives you the variation of the productivity. So you can see with motor manual pitching on bent sites, there was a great variation in terms of productivity. So values of less than 100 pits per hour were recorded, but at the same time, almost 700 pits per hour were recorded, but with an average of about 400 pits per hour. But if you look at manual pitching, there's very minimum variation in terms of productivity, just by looking at the size of the boxes. So the point is, motor manual pitching and fully mechanized pitching, they put greater variation in terms of productivity compared to our manual pitching. But manual pitching is less productive than motor manual pitching and fully mechanized pitching. And then I spoke about pit density. What I did there was to measure each and every pit. After pitching, you measured the distance with the inner row and the intra row, and that will ultimately be converted to our pits per hectare. And you can see for motor manual pitching, where I say the maximum tolerance there, it was based on a 3 by 2.5 meter spacing, which gives you 1,333 pits per hectare. So, but then we put a 2% tolerance, which is the standard for where I was doing the research on. 2% tolerance will give you 1,306 pits, which is the minimum tolerance, and a maximum of 1,359 pits, which is the maximum tolerance, with 1,333 being the optimum tolerance. So you'd find that motor manual pitching, there was a tendency of not meeting the required standard of 1,333 pits, and the reasons for this, they vary from supervision to challenges when pitching, because sometimes when the operators are working, you can get to a rock or some roots, and they tend to avoid some of those areas, and thereby it tends to distort the specimen eventually. But with manual pitching, it was within range, though slightly above what is required on unbent sites. But if you look at fully mechanized pitching, it was more, in fact, on all, both on bent and unbent sites. And this is, from experience, this very common. These results are not outstanding. It's very common that these are some of the issues or challenges that we face with the mechanized equipment. So I'm moving on to pitch quality. In terms of pitch quality, I looked at pit dimensions, starting with pit depth. And our pit depth in fully mechanized pitching, both in bent and unbent, was quite deep, and this was based on a standard of 25 centimeters width, and also 25 width and 25 centimeters deep. So you'd find that with our fully mechanized pitching, it was way above the standard. No any other method managed to perform is fully mechanized pitching. And generally, you'd find that the pits are more uniform. If you look at those bars, you'd find that the pits were generally uniform in terms of the dimensions, as compared to manual pitching, where you find that the center of the pit, because if you look here on our kit, it says left, center, right. So these are the measurements that were done in each pit that was selected. So the center, it just tells you how deep it is, and on the sides, how deep it is on the sides. So you find that our manually prepared pits, they tend to be V, so they are much deeper at the center compared to motor manual and fully mechanized pitching, where it's more uniform at the bottom. And then if you look at our pit width as well, we find that fully mechanized pitching had much wider pits than motor manual and manual pitching methods. And usually with the fully mechanized pitching or motor manual pitching, the size of the pit is a function of the the size of the attachment. So the bigger the attachment, the bigger the pit. So we'd find that with our fully mechanized pitting, we had a head which is more than 300 millimeters in diameter, and it tends to give you exactly the same or almost the same size of that pit. So same applies to motor manual pitting. It had a smaller drill bit, and it tends to give you a much smaller drill bit and a much smaller width. So the true dimensions, your pit depth and your pit width, it eventually translates into pit volume, and you find that the pit volume from fully mechanized pitting was much higher than these other two methods. And then that's the soil tilth that we got. These are just photos that I took from some of the pits. I couldn't take all photos, but as you can see, tilth from fully mechanized and motor manual pitting, it was quite good, with close less than 2 millimeters, and then more than 10 millimeters. And then these are the, I'll switch over to growth response results and discussion with the following indicators in mind for growth, which is the height, the GLD biomass index, corrected biomass index, and the stocking. So I'm going to take you to this busy table, and this is the ANOVA summary. So what I did, I measured this trial from day 0 up to 12 months. So with measurements being done, it's 3 months, 6 months, and 12 months eventually. So what this table tells us is, don't be worried about all these other figures that are inside, but what it tells us here is that we have got in the first column here, we have got the factors that are under investigation. If you remember in my introduction, I spoke about the 3 factors that I'm going to be looking at, which is the slash management, the pitching method, the 3 pitching methods, and also the planting method. So it just shows you the interaction between those 3 methods. And there on top is the time it was observed, whether it was at 3 months or at 6 months or at 12 months. And then you've got the different indicators that were under investigation, which is your height in the first column, in that column, your ground level diameter, your stocking, the stocking, and the biomass index. The ground level diameter, because with young trees, you can't measure DBH, because foresters were used to measuring DBH, but now trees that you planted on day 1, you can only measure the ground level diameter. So ground level diameter with the height, it gives you your biomass index. So in other words, you square your ground level diameter, multiply it by the height to get your biomass index. So the other thing, if you look at the bottom here, there's this 1 star, 2 stars, then NS. What these symbols stand for is the level of significance. So in other words, when you start to compare the means from all these factors and versus these indicators, each symbol here, it represents the level of significance. So for example, if I look at slash management on day 1, slash management on day 1, it had slash management had high influence on height, but not on ground level diameter. That's why it says non-significant there. And then if you look at, for example, pitching on day 1, it had influence on the height. So what I did with this table is that I went and plotted graphs that are of relevance. I couldn't present all the graphs, as you can see, but what I'm going to show you are only those graphs where that are relevant to what I'm going to be discussing about at the moment. And also, the second table is the same thing, just that the only difference is this one, it ranges from 6 months to 12 months. But I'm going to be focusing on month 12, because hardly people, they're not worried about what happens in between, but we are more worried about the yield eventually. So I'll go straight to the graphs here. On day 1 of planting, we find that pitching did influence the height, because what I did after planting, I went and measured all the heights, and this is the mean heights that I got from each pitching method, and this is regardless of the slash management methods. So you find that with manual pitching, it's a minimum height of about 24, somewhere there, and fully mechanized pitching, followed by fully mechanized pitching, and lastly manual pitching. But what does it tell us is that with manual pitching, you'd find that people, they've got a tendency of planting shallow. If it's manual pitching, obviously it's to do with the size of the pits. But with fully mechanized pitching and motor manual pitching, people, they tend to plant better, because if you remember, I showed you the soil tilt that we got in the from the sample that was selected. So we find that with better soil tilt, people, they tend to plant deeper compared to manual planting, which is called shallower pits. And then
Sorry, Jacob. If
yes,
you can maybe for time, time is limited, so if you can get finalizing.
Okay. So same applies to the second graph. Talks about slash management and planting, how it influences on height on day one, and mostly water planting on unbent sites tended to have better height compared to dry planting on unbent sites, followed by water planting on bent sites, and then at 12 months, you've got corrected biomass index at 12 months. Corrected biomass index, like I explained before, biomass index is a function of your ground level diameter squared multiplied by the height. But what corrected biomass index does, it takes into account your stocking. So it found that at 12 months, our biomass index from manual pitching was sitting on more than 15,000. The biomass index doesn't have a unit, so it's just a figure that comes as it is. So it was high in manual pitching, then followed by motor manual pitching and fully mechanized pitching. And that's why it's funny, and we need to investigate what is happening, because why is that we tend to have lower biomass index, corrected biomass index in fully mechanized pitching than in manual pitching. And then also it found that it was higher in water planting than in dry planting. This is not unusual, because obviously, because when you do your water planting, just shows that there's a benefit in terms of biomass index when you do water planting compared to dry planting. And then the stocking at 12 months, we had higher stocking in unbent sites than in bent sites. I think this is also not unusual. And also when it comes to planting, we had better stocking in planting, in water planting than in dry planting, though it didn't meet the industry standard of about 1,200 pits. But water planting had higher stocking than dry planting. And then in conclusion, fully mechanized pitching was more productive than motor manual and manual pitching. Then the pit density that was in fully mechanized pitching was higher than motor manual pitching and manual pitching. And then fully mechanized pitching produced deeper pits and wider pits than motor manual pitching and manual pitching. Then pitching methods and interaction between planting method and slash management method influence height on the first day of planting. And lastly, pitching and planting methods. I thank you.
Muedanyi, you muted?
Thanks, Jacob, for that presentation. And I think the work that you are doing is quite important, given the new technologies that various forestry stakeholders are exposed to. And it just paints a beautiful picture on some of the productivity as well as growth that can be expected. However, Again, it's research results that need to be replicated in various areas, and we can over time build a good database which can be reliable and can be used as a guideline. So thanks for that insightful presentation. Next, we are going to have a presentation from Helgard Steenkamp, and he is going to present on the topic of bringing precision to mechanized planting operations. But just a little bit on Helgard. Helgard grew up in a forestry environment from childhood. He always had an adoration for equipment and technology. After finishing school, he achieved his diploma in mechanical engineering from the Nelson Mandela University in Port Elizabeth, South Africa. Helgard also completed courses in forestry costing and supervision of forestry operations successfully. He is also a registered and accredited professional engineer by the United Kingdom Engineering Council and is an affiliate member of the Institute of Agricultural Engineers. His working career started as an assistant engineer at Novelquip Forestry, where he is currently the engineering director and design team leader. Helgard was intimately involved in the design and development of land preparation equipment, and that is very successful in South Africa. He also has experience in testing and developing of silviculture equipment in Brazil for the Brazilian market. Helgard was key in the development of the Spot GPS system dedicated for forestry and used on planting equipment to ensure a quality and accurate planting procedure for forestry. He was also responsible for design and manufacture of the complete wheeled carrier for planting heads and other forestry utensils such as bulk water supply. Helgard is knowledgeable regarding hydraulics, mechanics, and electronics, as he is also directly involved in manufacturing and operating processing. He is married to Nadia and they have 3 children. Thank you very much, Helgard, for being willing to give this presentation. I'll hand over to you. We look forward to hearing about your topic.
Thank you very much, Muedanyi. I just want to hear, can you guys see the presentation?
Yes, we can see it.
Okay. Thank you very much. All right. Hi, I'm Helgard Steenkamp from Novelquip Forestry. I would like to give you a presentation on bringing precision to mechanized planting operations, and then also laying the foundation for autonomous operations going into the future. Sorry, there we go. Key challenges in silviculture mechanization. One of the challenges is achieving consistent spacing with accuracy, hectare after hectare. It is difficult and stressful in manual or semi-mechanized operations, especially when running for long days and into the night under challenging weather conditions, as well as slash conditions, as we saw in the previous presentation. Slash also affects the stocking quite a lot. Inconsistent stocking is costly and difficult to optimize without the use of technology. Underutilization of land is basically a very big loss, because you could, by utilizing your land properly, you could get a better yield. The need for manual marking of planting spots is time consuming and costly in terms of planning, operations, and quality control for management. And also it's if you work in areas that are not burned with slash, it's quite difficult for the marking teams to walk and to move around. Manual recording of plantings completed for reporting and invoicing is inefficient, inaccurate, time-consuming, and costly. Skipping planned plantings increases your costs, drops your yields, and your productivity. Now, what I would like to do is I'm going to play the video on the right-hand side of the screen, and As the video is playing, I'm going to talk through the different things that you will see, how it happens, and just give a little bit of feedback on how and what is happening. This is a system that was developed by Novelcook Forestry. We've tried various GPS and guidance systems in the past from reputable manufacturers, and what we found is that even though they do have similar functionality, it was time consuming and it didn't really bring any value to the operations. Hence, Novelcook started to design our own guidance system, which increases the productivity of the machines. And I want to play the video and then talk everyone through it. Okay. The planning of your compartment can be done via an online platform that you can sit in your office at your desktop or on a laptop. And then you can use it. You've got a username and password. You log in, go to your compartment, and you can set up your compartment for what you want to plant. This can various different spacements can be planned, everything, and the different directions in which you have your rows can also be planned on the web-based server. So there you can see the yellow is the outline of your compartment shape. The blue block is your compartment that you are planning, and the direction that you saw me change, that was the direction in which to get your rows. So now you will just make sure that your compartment is within your bounds, and you will put in your X and your Y spacement. In this case, we use 3.5 by 1.5 and a default tolerance to which you allow your GPS to go. By use of RTX signal on the GPS systems, we can go up to 100 millimeters or 10 centimeters accuracy. And in this case, for the video, I used a 0.5 meter accuracy. You give your compartment a name, and then you save your compartment. Now, this on the video will take a short while because this function depends a lot on your internet speed. The higher your speed, the quicker the calculation. But what happens is it sends all of your information through, and then it gives you your compartment with all of your seedlings, all of your information. It gives you the amount of pits that you should have in that space, as well as the size of the compartment. You will then export these pits as a CSV file to your machine, and then your machine will have a grid on screen that will be displayed to your operator. Now we have, okay, this is the machine interface. So you'll go to your GPS tab, you'll have your compartment name on the right hand side in the green. The yellow dot is the actual pitting position of your machine, of the head. The white dots are all the positions that you want to pit in. Now this can be either pitting or planting, or for that matter, any other operation that you use in silviculture, including water irrigation or fertilizer application. When the dot is red, it means that that is the closest point where you want to work to your pitting head, but it's outside of tolerance bounds. The system automatically snaps to the next point, so the operator does not need to select to which point he goes. He can set the rotation of the rows so that he can drive the machine in between the rows, and simply by moving the head, he can snap between whichever point is closest. And once it's green, it means it's within the tolerance, and he can then use or create the pit or plant. Once completed, and I just want to pause the video here. Once completed, the data is stored on the machine, and you can take that actual data. Every single pit is time-stamped as well as georeferenced. That information can then be taken via flash disk put into your desktop computer again and uploaded into your web server software. From that, you can then actually pull up a map like this. Now, this was an actual compartment that was done when we did our initial testing of the system, and there was a donga where they could not put, hence the lack of pits over there. But as can be seen, every single position where a pit was made successfully was GPS referenced and logged. So what happens is you've got your planned compartment that you send to the machine. Once you've finished pitting, you've actually got the actual information of where the pits are. So you've got your theoretical versus your actual. So if for instance, you wanted to make a pit, but you had an old stump in the way, and you pitted just in front or just behind the pit, the GPS system will actually reference the actual pit made. So when this information is then pulled back into your web server software, you can then use that information to drive autonomous harvesting or to drive re-irrigation or secondary operations, because you've got the actual data of where every single pit is. The other data that can also be obtained from the machine is, as I said, there are timestamped. So you can actually go and draw a graph of your machine productivity and see where and when your machines operated and how they operated. For example, between 8 and 9 here, that's when the guys had breakfast and maintenance on the machines. And then at 1 o'clock as well, they had a break. So one can very easily from here go and pull quite a lot of data and detailed logs with regards to what your equipment is doing and how it's handling. As well as with that, you can also get this per operator on the machine. So you can also see when an operator needs additional training or whether you've got a very good operator. If we just continue with the video, so, okay, that's just a thanks. So the reporting, the collection of the data and the mechanized operation eliminates the manual record keeping, because you've now got it already in Excel format as a .csv file. And you can then use that information to go back to your compartment with follow-up operations. It also gives you your stems per hectare of actual GPS coordinates of each and every single plant that was planted or pit that was made. It enables future precision operations such as autonomous re-irrigation, autonomous fertilizer and harvesting, and is compatible with other mechanized forestry solutions, including harvesting operations. And because you've got the actual positions, and you can then export those actual positions to a secondary function or a secondary operation, you have the position of that tree or that pit to within 100 millimeters of accuracy. That allows you, without using LiDAR or without having to go and scan for trees, to actually go to a single point in your compartment. It also allows the forester to select thinnings, if you do thinning operations, to select trees in your compartments, and the machines can go to the GPS locations that was indicated by the forester when he exports the data. Precision by digital transformation and telematics. There you can see a video clip of the prototype planter that Novelquip Forestry has tested in South Africa, in the Southern Cape, as well as we tested that unit for a year in Brazil in various conditions. We've tested it in different locations as well to see how it works with different soil conditions and everything. On this machine, we did the pit, we gave fertilizer, we sprayed a pre-emergent spray, we handled the seed, we planted the seedlings and we firmed them, and we gave both water or gel. In some areas we worked with a water cycle, in some areas we worked with a gel cycle. And I would like to come back to what Sean Biggs has mentioned about the illipots and the paper seedlings. One of the things he mentioned that mechanized in mechanized planting, handling of the seedling is difficult, and that was also what we found to be one of the biggest challenges going forward, is the handling of the seedlings. So coming back to the precision and the telematics, the platform technology applications going forward is mechanized pitting. There are a couple of machines in South Africa already using this GPS guidance system for making the pits and for reporting. We've got our first trial unit that allows remote login and remote data transfer. So the owner can sit in his office and log onto the machine and get the details or upload a new map without having to go to the machine. Then going forward, one can also use this for mechanized fertilization, for re-irrigation after your seedlings have been planted. If you have a very dry season and it is worth re-irrigating your seedlings, that's something they do in Brazil, for example. That can be done. Mechanized planting, as you can see, this unit also had the GPS system on. We tested it in Brazil as well with the mechanized planting, and you can then use this system with thinning and harvesting as well. The foundation of the plantation is the first step that's required for autonomous operations. If you've got a very well laid out compartment, it's clean, and you know where every seedling is, follow-up operations become a lot easier. It becomes a lot more cost effective because you've got a lot more control over your whole area. Then the key benefits of the system, I'm sorry, it streamlines forestry-related business processes. It reduces the reliance on spreadsheets and handwritten reports and improves management's ability to access information and make decisions. In our technology-driven age, information is the driving factor behind many decisions, and hence the more information you've got, the better information you've got, the more informed decisions you can make, and also the more timeliest decisions you can make. Precision and quality is consistent. Your stocking will always be consistent, and you will have the correct figures of your stocking, and your quality of your work is also consistent if you use a mechanized operation. Due to the precision of stocking, no marking for planting is required, and the need for supervision is reduced, as these functions are accurately executed, controlled, and reported by the system. Everything happens on the machine itself, and the operating system is very operator friendly. Using the guidance system with signal correction, you can have more efficient utilization of your land. There are different levels of accuracy or signal correction that can be obtained. The most accurate is up to 4 centimeters. And then obviously you can go up to half a meter, but the general one we use is an RTX signal correction, which gives you 100 millimeters. You can increase operating efficiency by making fewer maneuvers with your base machine and by snapping to your next GPS mode. Because your operator does not need to select to which point he wants to go next, the machine will automatically snap to the closest. Your operator does not need to take hands off of the machine to select the next positions. That reduces the amount of input required from the operator, and because you can work in a predetermined manner, the movement required by your base machine can be reduced quite significantly. Due to the fact that you've got your GPS grid marked on a screen, it makes working at night and double shifting possible, as manual pitting done at night cannot be done at night. With the machine and with the GPS system, it's very easy to operate at night, because it's not taxing for the operator to find the mark. It's all on the computer, easy to spot, so your productivity at night is also a lot higher. Seedlings and other inputs, such as fertilizer and irrigation, can be placed in the exact locations if desired, saving on the cost of these inputs and increasing the productivity of the entire crop. You can give water closer to the seedling, and you can also give your fertilizer at the correct distance from your seedling, so that your seedling can utilize the fertilizer as opposed to the weeds and the other things in the field. Easy to use by foresters, contractors, managers, and operators, and helps them to efficiently and accurately complete their tasks with all of the remote logging included. The system is very user-friendly, and as mentioned, it's on a web-based application. And the advantages of the web-based application is, as long as you've got a computer with internet, you can create a compartment. So for example, if you are not at your office, but you've got your laptop with you and you've got internet, you can create or update a compartment for your operators. On-demand or automated reporting of the total activities per compartment, per shift, and the total time involved in the compartment, the average plants per hour, stems per hectare, and actual GPS coordinates of every plant. That's, if you think back to the video I showed, that Excel sheet that you had at the top, that can easily be incorporated into your monthly reporting on your compartments or on your machines. Workflow planning and management of operations. It increases the quality and the ease of managing your operations, as your reporting is done, is recorded manually, or is recorded automatically by the machine, and that information can be then used to plan the workflow for subsequent operations, such as your harvesting operations, or your forwarding and your re-irrigation, etc. Compartment planning and optimization. You can create many smaller compartments within a compartment with the software. So for instance, if you want to change the direction of your roads in your compartment, or if you want to change the stocking in a compartment, all of that can be done. So one can easily change and go and see how you can optimize your usage to have the best benefit or the most stems per hectare for the given area. And as mentioned, the system can be adapted for any operation and any base machine. The system is compatible with any type of harvester. It's compatible with tractors. It can be placed on small excavators, large excavators. So it's really, the system is a loose standing system and can be used to guide basically any machine currently working in forestry. And then also the amount of data that you can record is also scalable. For example, different types of fertilizer or different types of inputs can also be added or taken away from the system. The conclusion, digitization and telematics enables precision silviculture and generates intelligence to optimize management. The novel machine management system, or the MMS as we refer to it, accommodates all areas of forestry establishment, management, from planning right through to operations and to reporting. Our unique, fully integrated technology is what foresters need from the office to the field and back again to get work done smarter, faster, more efficiently over the full rotation of your crop. And as people say, the work's not done until the paperwork is finished. And yeah, thanks, Muedanyi. I think that's all I have to say for now.
Thanks, Hakan, for that presentation and for sharing some of the work that you've been involved in. And as you indicate, some of the initial steps towards automation and an interesting platform that you are working with, and we're hoping that we can be able to see its use more and more, and its integration and ultimately throughout the value chain with other activities that need to be done. Thanks so much for that presentation. And perhaps just to keep everyone updated, I would just like to share the program as I speak for now, and we will be introducing Sean Mackenzie, who will be giving a presentation on how modernized silviculture can be achieved through simple and adaptable tools. Quite often we think modernization is getting the big machines, getting the fancy equipment, but modernization can be simply changing some of the basic way in which we do things and using simple and adaptable tools. So just to tell you a little bit about Sean. Sean once matriculated in 2008. I went to a golf academy whilst studying a business diploma part-time. I did that for 2 years, then decided to go and join my father, Alistair Mackenzie, in his business that focused on forestry, pesticides, as well as conservation, noxious weed control. That was 10 years ago, and it has been a great experience that I've truly loved and grown with the industry. In hindsight, my biggest regret is not going to study forestry straight after school. In my time working in the industry, I've done work in Ghana and Zambia on contract to help set up spraying operations and protocols. I've been lucky enough to travel to Uruguay and Brazil in an aim to bring some of the technology back home. We have been in the front line of modernization in forestry, where we have adapted our business to one that supplies the whole package in terms of not only pesticides, but also planting tools, spraying equipment, spraying techniques, as well as new products that have created savings in the industry. In my free time, I enjoy mountain biking and playing golf. I play club cricket as well as club hockey, which I really missed in 2020 due to COVID. So without wasting any further time, I would like to welcome Sean Mackenzie. Sean, welcome, and we are looking forward to your presentation.
Good morning, everyone. Morning, Muedanyi. Again, thank you very much for the opportunity. Obviously, it's a great pleasure to have such a big audience as opposed to the standard field days that we attend. Let me just get this up. All right, can you see it there?
Not yet. We'll let you know now. It looks like it's coming.
All right.
Yes, we can see it.
Got him. Perfect. All right. So thank you again. Basically, Muedanyi, you hit the nail on the head. We focus a lot on modernization, but we look at the simple factors. Obviously, we understand with Silvix that the bigger machines and everything in terms of full mechanization is an important part, but we believe that being able to find production and increase production simply is quite an important thing, especially for the smaller growers. Right, our aims in modernization and forestry. Okay, obviously increased production. A bigger problem that we have in South Africa and around the world generally is the cost of labor. The younger generation, and it's a real thing that going and it's been obviously Hellfire brought it up earlier, being in field for the whole day in the sun is quite tough. So manual labor isn't really a great job option right now. Then quality of operations, we need to improve the plant survival. This obviously comes from better pitting and planting techniques. Obviously, better survival as well as increased biomass. So then we need to look at keeping seedlings clean and growing without competition. That's where the chemicals come into play. Social accountability. Obviously, South Africa, high unemployment, it's very unrealistic, and it wouldn't happen where we can't rely on people to help out. So obviously, we cannot fully mechanize everything for topography reasons as well as social accountability. We need to keep jobs in the industry. So basically, from an increased expense of labour, we just need to take those people and help them become more productive. And this also obviously there's ergonomic standards that need to be kept. Obviously, a lot of our corporates are very focused on ergonomic standards and safety in the field. Okay, so straight into it. Basically, we'll start off with the Husqvarna motorized knapsack. What we've done is we've taken a 3-meter aluminium boom, and then we've basically made it a pre-plant or broadcast spray application. 15-litre capacity tank. It's a small little 2-stroke motor. We've off-center nozzles on either side and one flat fan in the center. From this unit, you're able to get a 9-meter swat. So generally in your 3x2 stocking, you're looking at covering 2 interrows with this. Walking at 2 meters a second, you're looking at a flow rate of 80 to 90 meters a hectare. So obviously, we don't want to talk about figures directly, but for 1.1 kilometers the person walks, they'll cover a hectare. So that will, if they walk at 2 meters a second, you can work it out quite quickly. This will make your production sort of skyrocket. Uses for this will be obviously your glyphosate pre-plant sprays. We really do like this because it improves your consistency in the spray, where you're getting a full blanket of cover. And also for us, from the chemical side with glyphosate, the lower the volume of water we find, you get the better results, obviously increasing your surfactant concentration. With this as well, and we'll touch on it a bit later, your grass and broadleaf selective. This is something that's growing quite steadily in the industry, where we'll cover this later on. All right, we were having some issues with the video earlier. Let's see how the video plays. This is covering both three.
Sorry, Sean, your sound is not coming through, but we can see the video.
Can you see the video? Great. All right. Okay, so that's from the short bit of the spraying side. Going on to the planting efficiency. Here you have the Fugger Plenty, the planting tool, as well as the Squam knapsack. So the Squam knapsack is basically a collapsible knapsack that we've actually got 3 other adaptations. You've got the planting tool. We are also able to put a firefighting lance onto it, as well as a watering tool. This is the planting video. So basically, we have an 18-meter knapsack capacity. It's a simple and robust tool design, enabling the people to operate and carry on planting their seedlings. We've got a cam lock hose connection. So basically, the principle behind this system is that you'll have a team of 2. You'll have one tool per team, 2 backpacks, and then each person, once they've finished with their seedlings and their gel or their water, they'll unclip from the tool and then go and fill up. While they've been planting, the other person then comes back with a full set of seedlings and gel, and then they move on from there. Right. Okay, direct application tablets. So we've got the Plant and Go, the fertilizer tablet, as well as the suppository. I'm sure quite a few people may have heard of the suppository tablet. What we've got there is an insecticide, imidacloprid, which is great for your sucking and chewing insects. Basically the brainchild of Bulwer, where white grub was a great problem at planting. So that has then moved on to then be able to control your Geniptis and Leptosabi and all those sort of problem pests. One of the greatest thing with looking at it, you'll see the tablet on the bottom left-hand side there. That's our standard 9-gram tablet. You're looking at cutting your costs on transport, cutting your product handling, and also application. Whereas your suppository tablets or your plant-to-go tablets, you're taking 14 kgs of products per hectare as opposed to 100 kgs of your DAP or your DAP lookalike if the guys are going at 60 grams per seedling. So straight away you're reducing your handling costs for your materials. A big thing about these is that obviously your nutrients, because we have a nitroactive, so the formulation of nitrogen that's in there isn't hot, so you don't have any phytotoxicity to the seedling. The big push or the big positive from our side is that you can put that tablet right at the root plate and not cause any problems. But everybody will know that if you put LAN or your DAP too close to your seedling, you are going to have problems with root scorch. Obviously, with this tablet, it's specialized for forestry, so stock shrinkage is also mitigated quite a bit. And also you're looking at your application accuracy. Obviously, when you're dealing with an inorganic granule fertilizer, you can have the great variance of how many grams exactly is being applied, especially nowadays where we're still applying with a small cap in a bucket. With this tablet, you know that you can break down exactly what nutrients you're getting at the bottom of the root plate. Okay, the bendy bar. What we've basically got here and what we've done, the bendy bar is a more recent derivative of the dribble bar, which is actually brought from South America, and then later on from Ghana. Basically, what we've been able to do as Roundup or any of the other generics that is a non-selective herbicide, and what we've done with this system is basically turned glyphosate into a semi-selective and infinite application, whereas we're able to apply the glyphosate very close to seedlings with zero drift and fine. A big one that the guys have found is that this has increased your spraying windows. Typically, the team will go out and start spraying in the morning. By 9-10 o'clock, the wind's picked up and they have to move. So looking at this video here, we are looking at the ring hoe alternative. Everybody knows that the ring hoe is a very expensive operation. You're looking at your loss of topsoil moisture and organics or humics. It's a high, the spray from the bendy bar is very high production in comparison to your conventional ring hoe. Everybody knows that a ring hoe on the day is great, whereas a couple of days later you're having regrowth from the roots that were cut, so it isn't actually a permanent solution. Whereas glyphosate, it's going to be sorting out the weeds totally. There's also zero chance of mechanically damaging the seedling with the hoe, which is what happens quite often. This video isn't playing, and there's a problem with my connection here. Yeah. All right. As you can see there, it's a very simple operation. All right. What can be achieved and what has been achieved, and where to from here with modernizing. We feel that we've done quite a lot in terms of your planting techniques, your spraying techniques, and the next step is going in the agrochem and getting new formulations and new active ingredients to do different things at planting. All right, so pre-emergent herbicides. Basically, this is already available to us. Mechanized is a great, a common pre-emergent herbicide, basically targeting your grasses and some certain broadleaves, as well as sedges in ideal conditions. Basically, from a cost point of view, we can't go to guys and say, right, let's spray the whole compartment. It's just not realistic. So what we are driving for is a pit-focused application. So you'll see there the picture on the left here. This was sprayed first week of December, basically post-plant. Metazoclor we are able to spray as a directed spray in the pit. And then basically, so that was first week of December. See there, that picture on the left was the 7th of Jan. So it's already been a month. And then you will see that picture on the right there is the 16th of Jan. You'll see that there's been quite a good flush of your sedges and your smaller broadleaves, but the pit is clean. For us, this was the best case scenario. For an operations point of view, to go and come through your Christmas shutdown, and come back in December and you've got a clean pit and you're not searching for your seedlings. For us, that is a great win. And very, very helpful for later on. So the guys were able to do a follow-up spray there on the right-hand side and not have to do a hoe, which would have been quite cost-effective or not cost-effective. Okay, in terms of herbicides and what's in the pipeline. Grass selectors. We have Clethodim and haloxyphop combination. This is not registered or not on TUPWIG as yet. It is a forestry registered product. So basically what we're able to do here is it's two different mode of action grass selectors. It's still relatively new, and the guys are looking at this in terms of a reduction in chemical resistance, which we're finding with glyphosate and certain broadleaf weeds. Registered to go over the top of pine, dukes and wattle. So obviously now we're looking at a much safer way to keep the crops clean from grasses as opposed to your glyphosate. And again, as mentioned with the Husqvarna boom earlier, this you can do over the top as a broadcast application. Obviously now you're going to look at increasing your production. Another exciting thought is that there is in the pipeline a registered tank mix with chlorpyrrolid. So chlorpyrrolid is a broadleaf selective, very good on wattles and your annual broadleaves like your blackjack or your Tutumbili or Canada, as you guys would know. So in essence, what we're looking at, and obviously we have to go through the registration process through Act 36, is that we're hoping within the next 2 to 3 years, unfortunately it doesn't take us long, is that we will have a broadleaf selective and a grass selective registered tank mix. So this is obviously, that'll be a huge step for us in terms of production and getting hectares sprayed, and obviously doing it safely without damaging our crop. All right, pre-emergent herbicides. So we've got flumioxazin and S-metolachlor. These two are actually on the TUPWIG approved list, and these. What you're doing is with the flumioxazin, we've got your annual broadleaf weeds, and then with the S-metolachlor, we've got most of your annual grasses, certain broadleaf weeds, and your sedges in ideal condition. Again, this is something we're looking at for a pit spray, if not a line spray. This, as I said, is a registered tank mix already. Okay, keeping the pit clean. As mentioned earlier, we've got our flumioxazin and S-metolachlor. There is going to be work done on adding glyphosate into this combination. Obviously in the trial phase of it, but having a registered tank mix of this, you can then look at applying it with the bendy bar. So what we've found obviously is that what's happening is a lot of the trends going forward is with the mulching and topper rolling become very popular, is that the mulching and topper rolling is happening, and then we are pitting and planting straight away. Whereas in the past there would have been a wait, or there would have been a burn, and then the guys would generally, if they weren't under a huge amount of pressure, they'd be able to wait for a flush, do a glyphosate spray, and then plant into a clean page, so to speak. Whereas that's not happening. We're getting flushes when the seedlings have just come through. So this option over here I mean, it's something that would be really helpful in terms of the glyphosate would be able to take your post-emergent weeds out, and then pre-emergent would be able to look after the seed that's coming into the system. All right. Thank you very much. Appreciate it.
Thank you, Sean, for that presentation. Quite an interesting one, and thank you for sharing some of the tools that are available. And lastly, some of the chemicals that are available, and most importantly, some of the work that you are doing in terms of upcoming chemicals that can be used in terms of applying and eradicating weeds. Just a reminder to all the participants, colleagues, and people that are a part of the webinar that we have the Q&A section. Please put your questions there. We will have a question and answer session at the end. Please just indicate who the question is for so that we can easily go through them at the end. We are seeing the questions on this side, and they will be published when we start doing the Q&A session. So please jot down your questions under the Q&A section area, and we will be able to respond to them at the end. Okay, right. We are going to now move on to our next presentation, and this time we are going to have a presentation which is going to be relatively practical on some of the things that we need to know in terms of modernization. The title of the presentation is Keys to Successfully Transition from Manual to Modernized Silviculture and a Contractor's Perspective. This presentation will be delivered by Nikki Gwende from Tutuqani Contractors. And just briefly on Nikki. Nikki is passionate about high technology in mechanized silviculture and has been with Tutuqani Contractors since 2014. Nikki has more than 20 years experience and exposure in silviculture gained through Southern Africa and in the international forestry through benchmarking tours to countries such as Brazil. He runs a leading mechanized silviculture company in South Africa that specializes in mechanized pitting, planting, and weeding operations. The operation also uses drones, which are unmanned aerial vehicles, and high-tech sensors in planning and monitoring. Nikki's passion is in business and operation processes, re-engineering, and providing innovative solutions to operations. He holds a BTech in Forestry from the Nelson Mandela University, as well as a BSc degree in Agricultural Economics and honors from the University of Zimbabwe. Nikki, thank you very much for your willingness to present, and we look forward to hearing about your experiences and some of the key things to take note of in terms of modernizing from a contractor's perspective.
Thank you very much, Muedanyi. Morning, everyone. I'm going to present on the title Keys to Successfully Transition from Manual to Modernized Silviculture from a contractor's perspective. There are many keys that one can think of, but from my presentation, I'm going to focus on 4 major keys. That is processes, number 2, machinery and equipment, number 3, people, and lastly, number 4, support from your client, because I'm mainly presenting this from the perspective of a contractor. On processes, you'll be looking at your high-level planning as well as your detailed operations planning. Then on machinery, you'll be looking at machine capability and site matching. And on people, you'll be looking at the new skill set that is required since we are now introducing machines where we are replacing where we were using manual labor. On processes, number one, what are we planning
Mickey,
for? Yes.
Are you sharing your presentation?
Yes.
I can't see it. We can't see this side.
Can you see it?
Okay, let's give it a moment for it to come through.
Maybe it's loading.
All right.
You can see
it. Not yet. Have you pressed the open share tray side on the button on your tab there? Yes, it's coming. There we go. Yeah, you can just put it on slideshow and then you can carry on.
Okay, thank you for that. I was saying there are four major keys that I'm gonna talk about. Processes, number one, machinery and equipment, number three, people, and number four, support from the client, because I'm mainly speaking from the perspective of a contractor. On processes, which is our number one, what are we planning for? We are planning for safe movement of people and machines. Number two, we are planning for improved operational efficiencies. Number three, we are also planning for improved machine productivities. And all the goal and the focus is for cost reduction, as well as to reduce environmental impact and to improve quality and consistency of our re-establishment program. On the high level planning, we are still on processes. We'll be looking at whether to block fail or to fail individual compartments in various farms or various plantations. The benefit of our block failing, obviously, to bring synergies in logistics and movement of equipment that come in the silviculture side. Then we'll also be looking at whether to ban or not to ban. When you ban, your compartments will be clean and there will be easy access for all the machines that you'll be bringing in. I know in Brazil they don't ban. This presents obstacles from the slash and the residue that is left from harvesting. Well, from a high level position, you would also want to know farms or plantations that are suitable for mechanization through your slope classification. Then again, from your high level planning, which is like your strategic objective that you need to have in place, you will be looking at whether to mulch or not to mulch. That is removing your old stump lines as they present obstacles. And if you are mulching, what is your strategic objective? Are you going to go 100%? Obviously, 100% is expensive. You will not be able to do it. Are you going to go every fourth line? Are you going to open every sixth line? Or you are going to open double lines every sixth and seventh line and try to have synergies with the preceding harvesting operations that will come in later after the rotation period to open up space also for the forwarders that will be going through. So this would be more like from your high level planning, where you come up and draw your strategic objectives. Some of the tools that you would use, obviously you would go physically and assess physically, but you can also use drones to get aerial images of your plants so that you are able to capture each and every corner of the compartment. The detailed planning side, after you have considered your high-level planning, would include identification of obstacles in the compartment, that is your harvesting, residue, stumps, gullies. Once you identify these, they form part of what you call your infield conditions, and your infield conditions determine the speed of your machinery. All the productivities that you would have you would be aiming at are dependent on the speed of the machinery infield. So you are supposed to have identified the obstacles, such as harvesting residue, stumps, and be able to deal with them. Then you also have to, when you go out to assess your compartments, you also have to look at soil conditions. The soil conditions, this determine the pitting and planting times. And the road bends as well as the edge of the rod, they determine the turning times. When you turn, are you turning at the end of the compartment, or we are going to take more time, 2 minutes, because you cannot turn.
Sorry, Nikki, are you still there?
Muedanyi, can confirm you can still follow me?
Okay, yeah, now I can hear you again. I can hear you again. Nikki, you still there? We've lost you here, Nikki. Nikki, can you hear us? Okay, it seems as if there is. It seems as if there is a connection issue with Nikki's presentation. It seems as if there is a bit of a connection problem with Nikki's presentation. Chanel, is he still online?
No.
Okay.
Looks
All
like
right. So we will maybe. Okay, we will maybe try and go back to him a bit later on. But since we do not know the status of his connection and when it will resume, we will proceed and then perhaps move on to Dean. Again, just to give you what Dean will be talking about, Dean will be presenting on the title of Challenges and Solutions to Modernizing Silviculture at a Large Scale. And his presentation is going to cover mainly from a corporate perspective how the process of modernization has been in terms of challenges and solutions. But briefly about Dean, most of us know Dean, but he has spent 36 years in the employ of Mondi. He did his diploma with the Nelson Mandela University from 1983 to 1985. He also spent 3 years as a silviculture forester in the Graskop area before moving to tree improvement department in Sabi. He was then transferred to Pietermaritzburg in 1990 and has occupied a number of silviculture related technical positions over this period. Currently, Dean is the senior silviculture specialist for Mondi. He is a father to a wonderful daughter named Madison Grace. Interests is that Dean enjoys gardening, classic cars, and military history. And currently, he is trying to finish his PhD through the University of Stellenbosch, and he says hopefully before he retires. Dean, thank you very much for your presence and your willingness to give this presentation this morning. And we look forward to you sharing some of your experiences from a corporate perspective.
Thank you, Muedanyi. Can you hear me okay, and can you see the presentation?
Yes, I can hear you, and we can see the presentation.
Okay, fine. Thank you, everybody. Just to give you a perspective from a company, I'm sorry that Nikki's presentation couldn't go ahead because I think it really coalesced very nicely with this one. But I'm going to give you a very broad perspective on our modernization journey. So the start, just an overview on some of the terminologies that we use, Monty Forest in the context, industry challenges, some key drivers, factors around safety, ergonomics, and international competitiveness, and then our focus areas. And then a very important field that's coming to the fore for us is modernized firefighting, and then a brief summary of our learnings. So if we look at the terminology, we tend to use modernization and mechanization quite synonymously. They're not. We need to understand that modernization can be an ergonomic, a safety, or a technical intervention. It can range from a better hand tool, Sean McKenzie made a comment on that, to a fully mechanized operation. So mechanization is really the introduction of machinery to an operation as part of the modernization. And I think it's very important, please, that we use these terms quite carefully as we go forward. So just a bit about the company, Monty Forest. A number of you will know the company, very focused on short rotation, plantation forestry, a big focus on the planting, maintenance, crop protection, and more and more so fire suppression operations. We are bench well with our international competitors. Today we have a visitor from Brazil, and we see them as a very strong benchmark. In terms of low-cost pulpwood production, we're not self-sufficient in pulpwood supply. It's not our intention to be. We're about 75% self-sufficient, and we source on the local market. FSC certification is very, very strong. Monty has been one of the leading proponents of this since 1997, and we are a fully outsourced operational company since 2002. With quite a nice blend of operational internal research models that we can link up very well with our contractors, the example being Tutugani, we'll speak to you soon. In 2012, we started on an earnest program of modernization. We had been progressing very well in terms of our harvesting, and we realized that silviculture had to make some inroads. So our focus was primarily around safety, ergonomic, productivity, and costing. And we accept, like everybody has made mention of, that we work in a very complex socio-economic and political environment. Land reform issues, rural unemployment and poverty, water licenses, these are all factors that drive us. But again, even more difficult, we sit with abiotic and biotic stress factors. Drought, pests, fire, all of these are always going to challenge our industry. So earlier, there was a mention made regarding the workforce challenges, and this is one of the factors that did drive our focus from 2012. There is an aging rural workforce. There is a very clear understanding in South Africa that we have a young population, but the young populations are moving towards the more attractive urban areas. So your aging workforce, anywhere between 38 to 50 years old, and strangely enough, a 5% annual decline as people move to more attractive centres. Labour costs had started to increase. Very high labour turnover, again driven by rural-urban migrations and absenteeisms, anywhere between 10 and 20%. And if you look at world standards, those are both very, very high and very, very difficult to manage a business in it. Very concerning were there many problematic health conditions. We should never underestimate the impact that HIV has had on our people and continues to do so. In areas greater than 30% through tests. Then there was also a very big productivity quality challenges from manual operations, poor ergonomics, and we understood and accepted that the need to move from a physically demanding to a more cognitive approach is essential. So using machinery more than using bare brute force was absolutely essential, and I think you see at the bottom of the screen a slide that shows manual picking operations to the movement towards a handheld motor manual tool towards the more advanced impact type pitter. So in our drivers towards silviculture modernization. It wasn't a knee-jerk reaction to say, well, we need to do this because everybody else is doing it. Specifically from our journeys to Brazil, we had to sit and say, what are the factors and drivers? And there were some factors that came up very clearly. So the first one was concept of decent work. What are we doing? Is it decent? Improved working conditions, absolutely essential for ergonomic interventions. Eliminating safety risks, especially sharp tools. Anybody who's done investigations of the use of these and major incidents will realize just how dangerous they can be. Exposure to harsh climatic conditions. I think if we take for granted just how tough field conditions can be, and then the exposure to this monotonous work, which often leads to incidents or accidents happening. It was also important for us to strive for a more stable, educated workforce that would be part of the company's contractor workforce. And then how could we improve productivity and optimize silviculture operations to remain internationally competitive, because we have to remain low-cost pulp producers. So in terms of safety, we looked at figures going back, and we looked at total recordable cases, and in 2011 we experienced 100, and this was, in our view, unacceptable, and management was putting a lot of pressure on us, especially at your internationally trading companies. And just the interventions since 2012 have shown up to 2017, and it continues to decline, a great improvement in the number of or reduction in safety issues. So this is a positive spin-off of, and we should all embrace this very strongly. This slide, ergonomics, and I'm not an ergonomist. We have a highly qualified person in our company who continues to deal with this. But in 2012, as part of Mondi's mechanization journey, we focused strongly on all job descriptions that we could in terms of harvesting, silviculture, nurseries, an array of them. And then we're not going to go over them there. But what we did, and working with the experts in this, we said, what is the ergonomic risk cutoff value? And that cutoff value is about 30%, which meant anything above the line is really where you don't want to be. You really need to be below that 30% ergonomic cutoff value for work to be in an acceptable, sustainable format from an ergonomics, and hopefully to ensure the safety. So when we looked at it, we started to realize we had to start highlighting and prioritizing those jobs in excess of the margin or the line, and look towards how we could modernize them. So as if, and then I'm talking to many foresters, and having been a forester a long time, if I looked at forestry for, in my own perspective, silviculture, we hadn't made, and if we were really honest with ourselves, we hadn't really made great ergonomic developments for over 30 years. And it ranged from a person using a pick, to people carrying trays into the field, to very poor ergonomic posture in terms of planting. And we know that these were poor because our ergonomic specialist studies showed that there were significant musculoskeletal threats long-term involving this. People don't tend to come forward with these issues, but they exist, and I promise you, you only realize that when you start to investigate them. So very important factor that drove our modernization. The other factor is that if you look at this bar graph that goes to 2016, this is our US dollar oven dry metric ton in terms of our pulp prices. And if you look where South Africa sits, we were sitting in 2016 at about 84 US dollars per oven dry metric ton. It is very important that we move towards the left. If you look at our competitors, Canada and the Eastern Canada, Indonesia, the Northwest US, Chile, Brazil, Northwest Russia, all cheaper than us. And so what do we have to do? We have to push our margins of competitiveness towards the left to lower that. I mean, I think that's absolutely critical. So what did we do in the company? with this whole focus, we said, right, let's break it up into sections of work driven by safety, productivity, and then technical interventions. And what we wanted, we realized, and some of our major focus was to modernize all silviculture operations, try and standardize tools, power tools, for use in terms of training and operational skills transferred across areas. Phase out unergonomic work because of that graph we showed you earlier and the cutoff values, and reduce exposure to sharp tools. In terms of productivity, we have a very good productivity study group. We needed to standardize our establishment operations and improve on the quality of operations in both mechanized and semi-mechanized operations. So some operations you will never get to a point because of terrain that it's fully mech, and so your semi-mech operations have to stay abreast with that. And then something that we needed, and we learned a lot from Brazil about this, was the focus and quality through increased auditing. And I think we are starting to learn the importance of that. And I realized from my visits to Brazil just how much attention they pay to it. And I think there's great learnings for all of us in this country to apply more of that. In terms of technical challenges and focuses, we have very steep areas, and I'm talking generally anything above 20%, rough terrain, rock-strewn areas, which all impact on silviculture. So you cannot apply mechanization to every site. You're going to have to look at operational ergonomics, and you're going to have to look at your terrain. Then we want to look at integrated silviculture technologies. You've seen earlier spoken by Elgard on this, and this is work in progress, and a focus on a value chain solution. Can we do something from harvesting that will impact on silviculture? Importantly, when you get to high-tech expensive machinery, if you take, for instance, the cost of a modern mulcher in South Africa, you cannot limit it to one contractor or one area. You have to think more broadly and intelligently of spreading it across your landscape. So our silviculture focused areas, we said from the beginning, we have to exploit the best science and technology, and we have to ensure the sustainability of our plantations. So the areas that we focused on were, and we continue to focus on, is the residue management, the mechanized site preparation, mechanized establishment, and when we say mechanized, it could be still semi-mechanized, and a move towards the more automated forms that were addressed earlier by Elgard. Coppice management, which is a very challenging subject, but there has been some excellent interventions using power tools and showing that with the right productivity, the right training, we can actually get that to a much higher level. Weed control, very site dependent, but yes, there's lots of opportunity to use agricultural learnings. And most important to us was also how do we deal with fire protection going forward. So in terms of residue management, you'll all know, stumps are a massive impediment to our business. And trying to get machines done there, and Nikki will address this in his subject matter, quickest way to blow tires, detrack a machine is to ride over stumps like these. These relic stumps are dreadful, so you have to deal with them some way. So whether it's a destumping process or a clipping process, you have to have an intervention. Spreading slash, this is not a great operation. There are obvious safety issues and ergonomics involved here. So this is not an operation that I would ever say is a very good manual operation. Burning. Yes, we burn in South Africa. We have good reason for it. Our threat of fire is on a massive scale, but it does improve underfoot conditions, but we have to accept that there are site damages that can be done in terms of erosion. And even if you do burn areas, the bottom right, if you don't get your stump heights correct, we are going to struggle with damage to machine and productivity. So these are factors very important in terms of our residue management. Okay, so in terms of our equipment, not going to spend too much time on it. What we've done is we've said on a 0 to 20% slope, we'll look at more wheeled options if you want to destump, and above 20%, we'll look at tracked options. So from the top to the bottom, a whole lot of wheeled options, different equipment, local, international equipment. This is basically just a machine attached with a head, OE head attached to a Tiger Cat unit, a specialized stump grinding developed by Bell, and then just a basic Voltra tractor with a very good FAE head. We have an elite chainsaw team that does do stump removal or cutting back of stumps. They are highly trained, they have to be, and we actually use them only where necessary. And then obviously on the right-hand side, there are clippers that have been used very well in the central area. There has been there's been units attached to booms, and then the well-known OE mulches. In terms of pitting, you've seen this pitting unit. The Impact has been a great unit in our work. It has developed fantastic pits. It continues to do so, and very, very well used in Mondi. And there's a range of planting type tubes that we use. We've picked up better productivity. We've improved our ergonomics. And very importantly, exposure to chemicals and splinters has been avoided by starting to allow people to work in an upright format. And I can assure you that very, very few people in our teams would ever opt to go back to the old-fashioned route. A project we are busy with at the moment, and you would have seen earlier, I think it was presented earlier, you saw that unit, it's called a subsoiling unit. We are running a unit at the moment. It's our D6 with the Ecotil Savannah. The machine, the subsoiling machine is a pretty old design. Again, picked up again in Brazil that they were using them. We have some very, very good work in the Midlands going on with it, where we are using strip cultivation on sites that are less than 18% slope. And we are going across the slope, getting very, very good results in having no surface erosion on burn sites, some very good mitigation in areas where there has been erosion, and excellent water penetration into the rip lines. And we are busy with trial measurements on planted sites versus pitted sites, but there are limits to where you put this type of machinery. And there are also a focus that this brings to it is that it does a de-stump run in one way and it does a subsoiling in another. But how you run the machinery is very, very important, and slope does play a role. Our semi-mechanized planting in flatter areas moved across to gels still coming out with booms, tractor drawn. There are a range of these, and they are very successful and working very, very well. And I foresee them going to be continuing for some time to continue. In some of the steeper areas, this has been some very interesting challenges. In areas where we have anywhere from 15% up to 25%, we are running some specialist equipment. This is the top picture shows one of our skidder units up at our Ntonjineni area. Been very well used. The contractor up there has got many, many years experience of using this. The equipment in the bottom left is a Fiore unit that we developed with Melchart and Enco, and Tutukani now uses this very successfully. And then in the bottom right corner is a tractor, a John Deere tractor with tracks that's also used on steep area terrains. All successful in their own right, but quite specialist equipment, lots and lots of attention to safety and accessibility with these machines. So if you have any doubt as to your knowledge of them, be very, very careful with this type of equipment. It must be done with skilled contractors. Chemical spraying. Sean has been spoke quite significantly about this. We know that there's the advent of the remote pilotless vehicles. They are coming to the fore, but there's still going to be an opportunity for tractor-mounted tanks. We have some very good opportunities and had some very good experience with aerial spraying under the right circumstances. And there will be areas as well where we will still use people. This is what we would hope to regard as moving towards more modernized in terms of the ergonomics for the person. Coppicing. We are totally avoiding hatchets because of the number of incidents we've had. And we've been very involved in a project to use power tools. The top right corner is actually a electric-driven power tool, and then a good old-fashioned petrol-powered unit. And we've had some excellent results. And if you have a look in the bottom right corner, that is the type of result you can get in a coppice operation, which I would say is as good as anything you'll see anywhere around the world. I've seen In Australia, I've seen some of their coppice operations, and I would rank this by far superior. So coppice operations, right training, right equipment, you can semi-mechanize that very, very nicely. Pole pruners, very good work coming out of it. This is actually in a tree breeding trial where we started to test how you can work with these pole pruners. Looks very long, looks very difficult to manage. The center of gravity is well positioned, and our teams are showing great development with these. These pole pruners are working very, very well. You have to be aware of the maintenance of the heads. You have to put a lot of emphasis on your training, but there's very, very, very good results from it. So in the next two slides, all I'm going to show you is from any time that you do a modernized operation with a mechanized component, you have to consider your establishment suite. So on a 0 to 20% slope, from destumping to pitting, spraying, planting, blanking, and fertilizing, the contractors choose a suite of equipment that is suitable for it. So a Zululand contractor will choose a very different suite or a more mobile suite suited to a flatter terrain than what you would see in an area where it's greater than 20%, where there's going to have to be a focus on more track type machines. There's going to be a focus on more specialist equipment, i.e. this mulcher, the impact works across the landscape, this type of tractor with tracks on it, your type of skidders, which are able to cope on areas that a normal agricultural tractor wouldn't be able to. And never forget that we are still going to have the people component who will plant and blank and fertilize in those areas where we can't get machineries in. But the challenge is, how do we make their jobs just that easier? How do you do this for hours on end and not exhaust somebody? So I think it's a big challenge, and we haven't got that 100% yet. So productivity, just to give you an idea, in terms of from 1980, and we've obviously taken the figures out because they don't mean a hell of a lot, but all I can say to you is in terms of just a planting productivity, going back to 1990, where we had open root plants and people using trials, and we stayed that way for 30 years. We saw very little gain in productivity, but from 2012 onwards, we are seeing greater and greater potentials in productivities, and this has to be how we make our companies just that much more internationally competitive. So the last section just to deal with is fire, and I think when we go through silviculture, we tend to neglect this option and an area that is absolutely critical to every silviculturist. If we don't deal with the fuel load management, our greatest threat, we will lose our plantations. So top left corner, you will see these throughout South Africa, compartments like that, and the more and more we see that, the more we realize in the changing environment, you're going to burn yourself out. So our ways of dealing with it, yes, we do burn. Yes, there's challenges and there's going to be mounting pressure. We know in Brazil, they had to stop burning. So what is the future for South Africa? But what we do have to do is we need our compartments to get to the stage where you can't burn them. You haven't robbed the nutrient load off of it and you can access them. So yes, this is maybe a little bit idyllic, but it's possible. And I think this is where we need to move to. Absolutely imperative. Fuel load, if you've got it, you can't turn around and say, I'm just going to ignore it and hope it goes away. It will result in you losing your compartments. So disking, very strong part of our drive in Mondi. We've seen great benefits from it. This picture on the right side is something that Nikki will talk to you more about. It's a machinery that comes out of the Dumbi area, where you find that you can't disk. The flail has worked very good, but this has to be work in progress all the time. In terms of our equipment focus on our firefighting units, lots and lots of focus, much influence from Australia in a 2014 visit, where we realized that our trucks had to go a major improvement. So the safety of the crews, the ergonomics of the crews has been absolute exponential improvement in. We've introduced thermal curtains to our fire trucks. We have now introduced auto reels, besides other interventions, too many to mention here. But we are working now with smaller crews, 4 to 5 people, highly trained proto teams who will work in the top right. We introduced the first suite of double cab fire tenders that we see very common in Australia and around the world. Our designs are a lot more modular, a lot more standardized, and mechanization or mopping up in fire lines is something we're focusing on now. We're also working on CAF units, which are this bottom right corner. And this year we deployed, we have 3 CAF units. We have a smaller mini CAF, the midi CAFs, and then a mega CAF units. We are deploying more and more of these compressed air foam fighting units. They are very fast at suppression. They're very good at post-extinguishing protection. They preserve your water or conserve your water and improve its efficiency by up to 8 times. And you can use much smaller crews. You can withstand much higher radiant exposure for longer. And if you pick the hoses up, they're 2/3 the weight of a water-filled hose. So you're having this team here, this was an area manager and his assistant who extinguished this fire in a time that the crew were battling to leave. And I'm talking about a well-trained crew who were still on the road getting to the fire where we could hit it with these CAF units. So yes, this technology is in South Africa, homegrown, really up there with the best in the world. And I think we need to exploit more. So in closing, what have our learnings been? Modernization goals have achieved better than we anticipated. So we made greater gains from 2012 until now than we ever did in the previous 30 years to that. There was initial resistance, not everybody bought into it, and I think it's important. We need to know how to buy into this program on an equal footing. Innovation cannot come from a bunch of technical people, propeller heads. It's got to come from foresters and contractors alike. You cannot force this down. It's got to be an absolute encompassing, and this is key to our success. Job losses, we've offset to a large degree with the Zamele project, which is an initiative to create employment, and it's been very successful and ongoing. Some equipment, we have to acknowledge some did not work, and I think you've got to accept you will have failures. So be prepared to accept those. When they fail, fine. You're going to have to develop multi-skilled workers going forward. The days of somebody having one set of skills, that's not what we want. Supervisors now are a different level of training, much more challenging, much higher levels of responsibility, and the levels of training that you have to go through with this, because of the potential injuries through mechanization, has to be much higher. So I think it's very important that we take into account a focus on attention to detail and planning, and you're never modernized. It's an ongoing process, and good luck in that process. Thank you.
Thanks, Dean, for that presentation, quite comprehensive. And I think you touched on a number of important concepts. And from a corporate perspective, I think it is quite beneficial in terms of understanding the core drivers, as well as having a holistic process of identifying various interventions and managing various activities accordingly, and then modernizing as required. So thank you for that presentation, and that was very insightful. We will try and reconnect with Nikki. He has managed to restore the connectivity. So Nikki, I'm not going to reintroduce you. You can just proceed where you left off if you are available. Let's see if we can get Nikki to get his presentation on and just proceed. Okay, yes, I see there's a presentation. And Nikki, you are live.
Thank you, Muedanyi. Sorry for that technical glitch. I'll take you through and try to recap. I was talking about processes. Number one is a major key, machinery and equipment. Number three, people. Then number four, support from the client. And I think I was on this slide where I was talking about the tools that we can use for our modernization, which is the drone. The I'd also covered the detailed planning section where I was talking about residue analysis, stumps, gullies and stones as some of the obstacles that we need to go and identify in field. And I was saying these are in-field conditions that can determine the speed of machinery. And we also must go and check on the soil conditions because they determine the pitting and planting time. The road edges as well as the road banks, they determine the turning times of the equipment. So to take you through the detailed planning that we do in our organization for mechanization, we cover through an 11-point plan that is unique to our planning processes. We cover through number one, converging plant lines. We look at the frequency of our planting lines. How much are they occurring in the compartment? If they are new, it means that the compartment is relatively easy. If they are occurring 1 in 30, it means the compartment is difficult. And if it's 1 in 10, the compartment is very difficult to use machines because the machine would have to reverse every time it gets to a converging line. Number two, what we also assess there is the direction of line in relationship to slope. It is easier to move up and down a slope than to move across the slope. And moderately, you can also move, your planting lines can also be at 0 to 30 degrees. Then point number three that we use to in our compartment operations planning and rating is ground roughness. We look at the obstacles that are in the field, the obstacles such as harvesting residue, contour planting, and as well as gullies. We check on their height, their distance, and the frequency of occurrence. We have come up with a point scoring system where we say if there are no obstacles, it is a relatively easy compartment, and if the score goes up to 7 or 9, it is difficult. It means that the height and the distance between these obstacles and the frequency is too much. We also look at the previous ridges. Maybe the land was being used for agricultural purposes before, and we look at the height and the alignment of these ridges. Then we have got a scoring system. Then we also have got visual observation, visual obstacles. Your pruning height and your brushing height can hamper movement of equipment, especially under canopy where you are using your discs. If the compartment has been pruned up to 5 meters or 3 meters, it's a relatively easy compartment to move through. If it has not been pruned, it is difficult to get through because the branches will present an obstacle. The interrow spacement. The wider the spacement, the easier it is to go through. And if it becomes narrow or you've got interrow stumps from the previous rotation, it is difficult to go through that. The stump height and size. We look at the height, the diameter, and the multi-stems of the stumps of the previous rotation. And we've got a scoring system that we use. If they are occurring at a larger scale, it is difficult. And if there is none, it is easy. The soil conditions that we check on is whether the soil is wet or dry, or whether the soil has got stones or layers of a hard pan. And this affects our pitting. It also affects our planting because we'll be using planting tools. How to check this? We use a manual pick and check the penetration of the pick. If it is a full penetration into the soil, it is easy. But if it only penetrates up to 7 centimeters, it's a difficult compartment. And this has got a relevance in the type of machine that you'll be using, whether you're using a Versa planter or you're using a planting tool that is attached to the same mechanical planting equipment. Soil hardness will have an impact. Then we also look at the road edges, the turning conditions on the road edge, how is it, and the width of the turning area. Are you going to take 30 seconds to turn, or are you going to take 2 minutes to turn? Because this will eat into your productivity. So this, these two slides, which is the compartment planning and rating, this is like the fulcrum of our planning processes. Our foresters must be able to understand these points for them to be able to assess the compartment correctly. We previously, when we were on the journey on this mechanization, one would just deploy a piece of equipment into the field only for the driver to be calling us to say, I've got a problem, I'm stuck here. But because of this tool, we are now able to plan ahead before drivers are deployed, and drivers will become part of the process in understanding the in-field conditions. So this is central to our planning operations. You can see the effect of converging plant lines. This is an effect that is coming from a previously agricultural land that was being used as agriculture, and we had converging plant lines that happens on ridges, and we have got to mulch some of these for equipment to go through, because if an equipment is coming all the way, it gets to a scenario where it cannot go straight, it has got to reverse and turn and take another way. And the effect of this is punctures. Even when your tires are relatively new or good, you still have punctures, and it will affect your productivity. Then so these are some of the images that we come up with after we have assessed the compartments physically, and we have also used the drones. We will be having, you can see your mulched lines. This was every 60 line was mulched. This is where the equipment will be moving on each and every 60 line in this particular case. Then the yellow part, this is a portion where the slope was limiting. The equipment could not go there, was about 0.5 of a hectare. And on the red part, we had some rocks on this area. Then when we print these maps, our operators are taken through and they are shown where to go and where not to go, so that we have got a safe operation. And we also do the areas that the machine cannot go, we'll do them manually. So we'll subtract them from the total area for the mechanized portion. That is the other imagery that we can see of lines that we are following a contour, and our planting lines following a contour, and the mulched lines going through. You can see them there. Then point number 2 on machinery. On your machinery, it depends on whether it is a 4-wheel drive or a 2-wheel drive or a tracked equipment, and the slope limitations for a 2x4 is 15%. If it is a 4-wheel drive, it goes up to 20%, but it's not always 20%. It also depends on the type of implement that is being drawn. If it is being drawn, it is up to 20%. If it is on a 3-point linkage, like your spray rig or your flail machine, you will take it up to 15%. And we have got tracked equipment that can tackle up to 35%, like your excavator impact machine, but you must also synchronize it with the planting. Once you have pitted at that slope, which machine are you going to bring in to plant that area? So it may be limited to maybe 25%, where the Fiori can achieve the planting process. You don't want to go and pit and you come mechanically and you come and plant manually. Still on equipment and machinery. This is our typical mechanical pitting operation. Our teams stay in field for maximum efficiency and maximum productivity, and they have got a caravan that houses them, about 6 people, 6 beds. It has got a kitchen, bathroom, a toilet and beds, everything in field. It has got a fridge, lighting supplied by solar, and a gas installation for cooking. This operation achieves about 2,400 pieces per shift per machine. Our typical planting operation, which is the Fiori, it's a self-contained unit with 2 tanks, 1,500 liter each, and a gel mixer and a pump. Simultaneous application of the fertilizer tablet that Sean showed you, and as well as the planting operation going at the same time. You can achieve between 7.5 to 10 hectares in a shift, depending on the conditions that I've taken through on the compartment rating. Then we have got the Versa planter, where you mark, pit, plant, and fertilize at the same time. A simultaneous process happening, 6 planters behind the machine. It uses high pressure water to drill the pits. It is on a 3-point linkage, 800 liter tank using a hydraulic pump for high pressure to drill the holes. It achieves about 4 hectares per shift. This system, because it marks its piece and it plants, it has got a cost-effective advantage of 32% over the manual pitting and manual planting. If you combine manual pitting and manual planting and you compare it with this mechanized operation, it is also has got a cost advantage over the semi-mechanical pitting, the mechanical pitting using the impulse and the semi-mechanical planting using the Fiori. It has got a cost advantage of about 20%. So you'd see that in processes where you combine activities, you get cost advantages. Then we have got a chemical interrow weeding using a wind box. 3 wind boxes, 6 people behind the machine, average production about 8 hectares per shift. Then the line weed, when we spray the line, we use the dribble bar concept. Sean has talked about the dribble bar. These are people behind the dribble bar. 800-liter tank, we can achieve up to about 15 hectares per shift, and we use about 12 people, each pair taking a line, and they will be covering about 15 meters, whereas in the wind box they were covering about 9 meters width. Then this is a flare. You would see the picture on the top left corner. It has got weeds, and the flare is working there. There's some dust coming out. The effect after flaring, you see it on the right-hand side where the weeds have been crushed and removed. We achieve about 7 hectares in a shift using this flare machine. This is mechanical weeding. Then we recently also acquired a spray drone in our operations for spraying. The potential to spray 10 hectares in an hour is there. We are still trying to use this equipment. We have not yet get into it, but we have acquired it. It's now with us in our operations. The limiting factor there is the battery life, which the flight time for that battery is about 10 to 15 minutes. So you need to have a number of sets of batteries and continuously charging them. We also use sensors in some of our equipment, like the Husqvarna Fleet Services sensor that we use in our copies reduction. We come up with graphs that shows us a productive time and idle time from the machine that we'll be using. And we think this is one of the areas where we must develop more towards the use of sensors to collect data. Daily productivity monitoring, I'm still on machines. You need to be able to collect your data, and you need to be able to analyze it as an operation so that you understand what is happening. And currently we are working on a project where we want to integrate our production, our procurement, and our management accounts, such that from the production side, our foresters will be having tablets where they load in the production figures that they have done for a day, and they are captured live, and automatically management see it, and the reports are generated automatically. So they will be capturing information such as labor usage, the machine hours used, the fuel and the chemicals that they will have used. So this project is in the pipeline, and we are currently working on that. Then I talked about the third point is support from the client. It is very, very key that for you to have a successful transition from a manual to a modernized silviculture, you must have support from the client, good relationship. There must be mutual understanding of the compartment planning and rating. As you receive the compartments, you need to go and assess together and agree on the right category or the right rating of that particular compartment. Normally on your pricing, you know, from your manual, it's mainly the main day rate, but when you are looking at the mechanized operations or modernized operations, you also need to consider things like the impact of fixed costs during the off season. You need to consider things like logistics. There will be movement of equipment, unlike in manual operations. So there's need to consider that in your costing. Then there's also need to have a joint approach to research and development, time and work studies, so that the figures that you come up with as a result of coming together with your client. So that support is very key. You cannot succeed alone as a contractor. We are lucky that we are supported in our operations, and the vision and the strategic goals come from the client. And as we implement them, we'll be implementing something that has got support already. Then the last point, if you have got the best processes, the best machines, you understand the machine capabilities, you have got the best support from your client. If your team is not ready for mechanization, the people, then everything will stop. So you must have competent people, motivated people that are trained regularly. We train all our operators annually. Besides that, they've gone through, they've got their driver's license. They still go through our training programs where we train them. We also incentivize them in production incentives. We incentivize them by dividend sharing so that they are motivated. So this is one of the ways that we keep a motivated team, because we believe that with all the good processes, with all the right machines, with all the support from the client, we will not be able to achieve this if our teams are not motivated and they are don't have the skills. Then they must be informed, obviously, the teams. Once they are informed, they must know their production, they must know their the statistics of safety that is happening. Then, in a nutshell, I would say, I would summarize the major keys as processes, machinery and equipment, support from the client and your people. If that has got a good interaction, you achieve a successful transition from manual to modernized operations. Thank you.
Thank you very much, Nikki, for your presentation. And yet again, it would have been a pity to miss out on the rest of your presentation, because it provides very important information from a contractor's perspective on some of the key important things that need to be taken into consideration in terms of the modernization process. I'm sure there will be some questions and some inquiries based on some of the concepts you covered. Lastly, we are now going to move on to our presentation, the last one, which is an important one because it gives us a bit of a perspective on a global view. We are going to have a presentation here which is titled The Status of Silviculture Modernization in Brazil. And the presentation will be delivered by Professor Saulo Guerra from the UNESP University. And I'm just going to give a bit of information about Professor Saulo. Professor Saulo has a degree in forestry engineering from UNESP University, from the University of Universidade Estado Paulista. And the rest I cannot read properly. And he also has a master's degree and a PhD in agronomy, focusing on energy in agriculture at UNESP. He was a postdoctoral fellow at the University of Arizona, Maricopa Agricultural Center in 2010. Currently, he is an assistant professor at the UNESP University at the Faculty of Agronomic Sciences, and also part of the Department of Rural Engineering and Socioeconomics. He is also a coordinator of the research group called LAB, which focuses on biomass and bioenergy, agroforestry, as well as bioenergy research. So he's got a lab there which he focuses on research in that area. He is also the director of the Foundation of Agriculture and Forestry Studies and Research, FEPAF, and he was the director from 2010 to 2012, and he is the coordinator of the undergraduate course in forest engineering at the UNESP University, and he's basically been managing that from 2012 to 2018. In 2016, he assumed the scientific leadership of the cooperative program of forest mechanization and automation, that is PCMAF, of the Forest Research and Studies at EPEF. He is currently the Deputy Coordinator of the International Union for Forest Research Organization, that is IUFRO, Division 3, which focuses on forest operations, engineering, as well as forest management. Through Professor Saulo, we've had a good relationship with the UNESCO University, and he is quite knowledgeable in this area and very much in touch with the Brazilian industry. And I'm looking forward to hearing, and I'm sure everyone else is also looking forward to just hearing about what is happening in Brazil, what is the status, and what are some of the technologies that are involved. So without wasting any further time, Professor Saulo, I'll hand over to you to then proceed with your presentation. Thank you.
Thank you, Professor Muedanyi. I hope you can hear me and watch my presentation. Is it everything okay for you?
Yes, we can see your presentation and we can hear you clearly.
Okay, so thank you for this invitation and thank you everybody for attending this webinar sponsored by Nelson Mandela University and organized by Professor Muedanyi. And I will start my presentation just after your introduction, Muedanyi, introducing to the audience what means EPAF and PCMAF. So the PCMAF is a cooperative program of forest mechanization and automation. That is the cooperative program that I'm leading during the last 6 years. And the aim of our program is to increase the productivity with the high standards of quality in silviculture operation. It's really important to highlight here that we are not focusing in harvesting operation, logging operation, or road operations. Okay, so we are focused in soil preparation, planting, mechanization of irrigation, and maintenance further operations. So the main research lines could go up to precision silviculture and also robotics in our forests. Right now in our program, we have some projects undergo, and one of the key projects right now is the development of a forest tractor. And I'll show you later on some images and some features of those projects, such as 3-line irrigator, 3-line automated planter, and also the forest tractor. Okay, so the group or the cooperative program is organized over the IPAF, and IPAF is the Forest Research Institute, and we have as a president the dean of the Eldorado Brazil company, and he has one steering committee at the top level. But here on the ground we have one former professor sitting as an executive director, and under this director we have the scientific leader, then we have the executive coordinator, and graduate and undergraduate students. And side by side with me, we have a steering committee. And here on this category, on this group of people, we have employees from the forestry companies, from the industry side, and we are driving the PCMAF projects and projects on the go. So we have Angelo from Suzano, Cássio from Ceniba, José from CMPC, and Arthur from Gerdau. And inside this program, we have different associate industry, such as Bracell, Duratex, International Paper, Valorec, and Eldorado Brazil, building up the ideas, the thoughts, and bringing to us the real scenario to do field evaluation. So what we deliver back to them after we have a machinery evaluation, a field evaluation, we summarize all the activities on a technical bulletin. This is a very small piece of paper, and that could be electronic as well, to summarize the full evaluation report. So we understand that the people on the ground, on the daily duties, they don't have a chance to read like a 20, 30, 40 pages report. So we do it in a very brief and condensed bulletins, and it's very easy and handle for the audience. We also publish on the web what we call IPAF, PC Math news. It goes through email to our sponsors, to our companies, and also we have Monday online status. So all the companies and all the employees that involved on those particular projects could track online what we are doing, where we are, and what are the results. Here inside the IPAF, we have one robust platform with all the data, all the reports, all the images. So the companies that are associated to IPAF can go there and check it out, what we are doing. Also, we provide few days and demos for this public, and here I can show you just an illustration of what we can do. So this is our real scenario in terms of manual planting or manual operation in Brazil. This is not very much different than what you guys have in South Africa. I was watching the presentations before my presentation, and the structure is quite similar. The equipments are quite similar. The soil type conditions is roughly the same. And this guy, for example, is able to plant 1 hectare per day. So it's about 1,600 seedlings per man per day. And as you know, we are in a tropical country. It sometimes is getting very hot, and the labor condition is becoming more critical. So we need to move forward into the mechanization process. So the first step in terms of mechanization is to go with the semi-mechanized planters, and we have many different manufacturers, different colors, different accessories, and different solutions from their manufacturers to the forestry industry side. And also we have machines developed by the contractors itself. So this is just an overview. I just choose this image because it was a new machine, and you can get a feeling what we are doing. And this machine provides more productivity, and it's a little bit more comfortable for the driver and the operator or the planter guy to work on the ground, and we can increase the productivity. We move from 1 hectare per day per person for up to 3 hectares per day with 2 people, 2 labor. So it's going to be a slight increase in terms of productivity. But then maybe 5 or 6 years ago, we start developing in a partnership with different manufacturers and different forestry companies, a mechanized planting technology. So the first one to approach this new scenario was the Brachy planter, and he brought to us the latest technology back 6 years or 7 years ago, and we run a huge survey with them when we planted more than 220,000 seedlings, and we collected data for more than 22,000 seedlings on the ground. And this machine was capable to prepare the ground, to plant, to irrigate, and to fertilize at once in just one single stop. And that machine, the base machine, was fully adapted to carry more water, to carry seedlings, and also extra fertilizer bucket. And then moving on this research, on this development, and this partnership, we move from the single type P11A bracket header up to this P11B that follow the Brazilian design, or the Brazilian desire for a planting machine with the proper spacement between the seedling and the fertilizer billet, a bigger carousel, so we could gain in terms of productivity and operational field performance. And we move up to 1.5 hectares per day, but we are adding water and fertilizer with the planting operation. So you can see step by step the increaseness of our productivity, and that lead us to have the first planter in South America, capable to plant, irrigate, to prepare the ground, to plant, irrigate, and fertilize in just one single operation. So we keep working with this team, and you can see probably many familiar faces on this picture. And we came up to the first in the world semi autonomous and fully automated triple planter. So most of you have seen this video on the web. You can easily track on YouTube, but this machine was capable just to plant and irrigate 3 lines at the same time. And we were able to reach a very outstanding operational field performance, pushing up to 2 hectares an hour. I can tell you that we can plant almost up to 800 seedlings an hour with this triple 3 units at once. So that is a very positive increase in terms of productivity. However, if we move from the planting operation and the first irrigation, we need to keep irrigating sometimes up to 3, 4, or even 5 times when we are planting on our west part of a country. So that was the real scenario right now. We have a truck, a normal truck, a road truck with a water tank and a boom to spray water, and could be water and gel. But indeed, we still have a lot of labors in this operation. So we have, for example, in this picture, 8 people working, 1 tractor driver and 7 people on the ground. And that is not what we are looking for, new mechanized or semi-mechanized operations. So maybe again 7 years ago, 6 years ago, we start to develop new solutions in terms of irrigation, and that is the latest technology, that is an automated irrigation system. And here on the left side, you can see there's 2 booms, and those are robotic booms. Those booms are automated. They move sideways, and the camera and the sensor itself detects the seedling and moves the arm sideways to position the nozzles on top of the seedling. We still have lots of work to do to develop newer technology, newer algorithms, because during the daylight, we still have only 85% of assertiveness. And this is a huge potential technology for us, because when we work at nighttime, we can increase the assertiveness up to 99%. So there's room for us, researchers, professors, manufacturers, to improve and to increase the technology based on these visual cameras and visual the plant detection. So I brought you some information in terms of the field performance. So I saw on the chat some fellow asking about in what terms we did the measurements, and we did a very large survey for all the machines on the ground. So again, on this case, we evaluate this machine for 260 hectares, and you were able to see the field performance in terms of 1 up to 1.2 hectares per hour. So if we have 2 sets of this technology, you can match, for example, the triple planner field performance. So it's quite important technology for us, and it's been under development. And the latest improvement on that technology is the automated triple irrigator. And again, this is the first technology in the world. So we do have these moving arms on the right side and the left side of the truck. It's a conventional road truck. And we have the third nozzle here in the middle of the truck, on the center line of the truck. So we can irrigate 3 lines at the same time. So if we consider the soil preparation, then the triple planner, then we can come with the triple irrigator. We can be very maximized, we can be very productivity, or we can also reduce the number of labors on the ground. And you can see here an increase of an operational field performance, and we are able to go up to 1.6 hectares per hour with this strip line irrigator system. Okay. Moving to the future projects or ongoing projects, during the last 2 years we are trying to search for a forestry tractor manufacturer. We don't have a forestry tractor manufacturer in Brazil, nor a forestry tractor from abroad is sold in Brazil. So you can see, for example, multiple alternatives throughout the world. From example, from Tiger Cat, they developed this forest tractor, and they are using to spray herbicide with this new technology, and this is one of the solutions that we are trying to bring to Brazil. The first one we select came from United States. The second solution came from Forest Track, being produced by France. So that is an alternative for us. We can consider a highly steep terrain operation, and that is just an overview of the Forest Track products. Also, we found and we select a machine from Canada. So Awasos has this small forestry tractor, and we are not looking for a skidder with the grapple or with the cable. We are just to adapt these tractors for silviculture operations. And we also get in touch with the Iran guys. They have 2 solutions from Romania, a smaller tractor from 85, 90 horsepower, and a bigger tractor up to 120, 130 horsepower solution. And the one that is on the ground right now, and that is a completely new information that I'm bringing to the audience, is the Japanese tractor. The Japanese guys, they have this carrier with the rubber track solution. And right now we came up with this forestry tractor working as a sprayer. So the forestry companies, their engineers on the PCMAF cooperative program contribute with the solutions with the manufacturers. So we have here the FM coupling, that is a sprayer manufacturer, and the Muruka and Embark, that is the tractor manufacturer and dealer in Brazil. And we develop this solution. This is a wind box spray. It's about 2.5 meter width with what we call the wing bat technology. And this solution is adjustable, so you can select the height and you can replace this tool. So we have this protected sprayer equipment, and we also have a 12-meter boom sprayer on the same machine. Okay, so if you want to get more information about what we are doing in terms of the silviculture mechanization in Brazil, you can track us on this website. Unfortunately, this survey, it's in Portuguese. That is the third survey that we came out, but the first one that is published on the web. And I will tell you that next year in 2020, we will come up with our new survey on mechanization, and that will be in English. So just to summarize the survey that came up in 2018, that is an overview about our mechanization, silviculture mechanization. Right now, we have a representativeness of about 35% of the country, and these guys, they drives up to or close to 2,000 tractors. 68% of these fleet are based on just 3 manufacturers, and only 33% belongs to forestry company. The other 60% belongs to contractors. So if you multiply this number by 3, you should be close to the number of tractors working on silviculture in Brazil. Okay, so Muedanyi, thank you for inviting me and introduce you to this audience. I will provide here my email and also our website where you can download more information and you can follow us over iPath. So thanks Muedanyi again, and thank you everybody for watching us during this webinar.
Thank you, Prof. Saulo, for the very interesting presentation. You did show us some technologies which will possibly be of interest from a South African perspective. And right now, I would also request the presenters just to maybe come back and log on so that their cameras are on, so that we can then proceed to the questions and just general discussion session. I'm just going to move across just to look at the questions. I see some of them has been responded to already, but perhaps this looks like a common one here, and this will just direct to Sean Biggs, who can just respond about how long does the paper pot last post planting. So that will be for Sean Biggs.
Great, thank you very much, and thanks for that question, and thanks again, Muedanyi, for inviting me. Very good question, and I just want to make the point that there's no negative effect on the performance if the paper is longer than necessary. So The roots go straight through the paper and develop out radially from there. So there's certainly no negative effect on that. If I could just quickly share a slide. Can you see that, Muedanyi?
Yes, I can see it.
Okay, great. So just to explain how it works. So as Elipot, we have about 18 different types of paper, and there are different factors on the paper which probably more affect the nursery phase. So for example, how quickly they dry out. What probably affects mechanized planting a bit more is the tensile strength and then the degradation period. So you would like to match your degradation period to as closely as possible to your nursery cycle, but it's very important that that paper is still stabilizing that paper pot when it goes out to field to get those benefits that we were after. So for example, in this slide here, you can sort of see after how many months it starts degrading away, and we've got papers that go from 4 to 6 weeks right up to about 14 months. So you know what you want is you don't want it breaking down before you need it out in the field, but you want to degrade away quite soon thereafter. So it's really just about trying to find the right paper. Many of the papers that have traditionally been used have been the longer lasting ones, and there's a lot of work being done by forestry nurseries in South Africa and elsewhere on going with shorter cycle papers. Papers have the FSC certification, and yeah, and in terms of that phased approach, there really temperature and humidity play a big role there. So you can see the solid line is how long they'd last for, and then depending on what the conditions experienced are in the pit, that will determine how long it lasts for.
Right. Thanks, Sean, for that answer. And perhaps this will be directed to Jacob. We've got two here. Jacob, there's a question on how do we strike a balance between manual and mechanized operations, given that mechanization is viewed as a double-edged sword. It improves quality and productivity on the one hand, but results in job losses. And the other question simply asked, what is the pit size or standard? What is the cost per pit and hectare? Just remember to unmute, Jacob.
Okay, can you hear me now?
Yes.
Oh, okay. No, once more, thank you so much, Muedanyi, for the opportunity. But to answer to that question, I think it's Justin who asked that question on employment. I think the reality is that we are going through the 4th industrial revolution, and forestry is no exception to this. And you can see from all the presentations that have been here, that is all pointing out to achieve the objective of the 4th industrial revolution. So forest is no exception, and unfortunately that's where we are going, and to remain competitive as an industry. So but at the same time we can't rule out manual pitting completely, because I think the worry is on doing away with manual pitting. We cannot rule out manual pitting as such, because if you look at mechanized equipment, it has got slope limitations. So you cannot go 100% because with mechanized soil prep because of slope limitations and the other factors that we mentioned earlier on. So the assurance is still there. There's still employment available in manual operations, but yeah, as an industry, we need to be seen also to be working on achieving the 4th industrial revolution. And then on the pit size, it was anonymous. Okay, pit size, the standard that I was working with is normally 25 by 25 centimeters, which is 25 centimeters wide and 25 centimeters deep. But with mechanized equipment, like I said, you'd find that the size of the pit is a function of the attachment that you put on either the auger or on the pitting machine. So it all depends on what size of the head that you have attached to that machine. But I think more importantly, the pitching depth is more important than the width, because normally if you don't achieve the right pit depth, you end up it will result in J routing as well as shallow plants. So that's what I can say on pit depth. Sorry, on pit size, yeah.
This I think was dedicated to Hellcat. There's two. I see there's some responses, but maybe you can just give an overall brief response. The first one was from Jose. He asks, can we see immediate cost reduction in precision planting, or are the benefits long-term? And secondly, there was a question from Anonymous which said, a forestry machine guidance system such as Novel Quips is already available from some European countries. What sets Novel Quip apart?
Hi, can you guys hear me?
Yes.
Okay. The first question is, it can save in the short term and in the long term. In the short term, it depends also on how your operation is run, but you can do away with marking. You can also use your pitting machines to remove slash, so you can get away with or not can get away with, but you can save costs right from the start by not having to mark, not having to remove slash, etc. And then also you can extend your shift length to work into the night, which you can't do with manual operations either. So yes, definitely you can utilize your equipment better, and by utilizing your equipment better, you can save costs. So from the get-go, yes, you can save costs. Obviously, there is a cost implication to the guidance software, but that should be able to recover that quite quickly. And then also for follow-up operations, it definitely saves in the long term, especially if you start looking at precision operations going forward, because you can use the same system once again because you know where your seedlings are. And then the other question with regards to European GPS guidance systems, those tend to be machine or manufacturer specific. What makes Novel Quips unique is, number one, it's not manufacturer specific. You can take this system, you can put it on any tractor, you can put it on a 3-wheel logger, you can put it on the Forester's 4x4, you can put it on a harvesting head, you can put it on a pitting machine. So it's really any mechanized machine can use this system. It's not manufacturer specific. Then also it's available for the whole value chain, so it's not designed simply for planting or pitting alone. It's designed for being everything from harvesting. You can start with a system on a harvester, and then once you've harvested all your trees, you have your old rotation positions. So you have your stump positions, so you can then go and plan your silviculture operations to minimize your downtime with regards to being on the old stump lines, because you've already got the position of every single tree. So it's very flexible. Then also what I've written down here is ours is a spot GPS system, meaning that when the machine is standing still, you still get the 10 centimeters accuracy. Many of the GPS guidance systems needs the machine to be mobile to get a heading location, and with that, it calculates where it is exactly. So this system is a little bit different. It's designed to work at a specific location, even if the machine is stationary. Then with regards to another advantage is cost, and I think user friendliness. With the fact that you go online and use a web interface, you get a username, you get a password. So you don't buy a specific software package that is installed with a license onto a specific computer. Because then you are limited to using that software on only that specific computer. But what happens if the person who does the compartment planning is away on leave? You're stuck because you can't use his computer, for example. So by being able to go online with a username and password, you can be anywhere in the world to do that. And we did that when we did our trials in Brazil. Some of the compartments were, while we were busy working, the planning was done from our company in South Africa, and the files were sent over. I think another thing that I've neglected to mention in my presentation is just that we can use any KML or any GPS data file to import boundaries, etc., slope conditions, etc. So it is very user friendly. It is still work in progress. There are a lot of additional things that we still want to add and which we will still add. But I think from that point of view, it is quite flexible as well. I hope that answers the questions.
Okay, thanks, Gerhard. These next two questions will be going to Sean McKenzie. The first one says, how effective is the application of pre-emergence for pre-plant spray after burning the compartment? And secondly, the question says, during your presentation of using knapsacks to apply herbicide, is it not necessary to wear appropriate PPE when applying the herbicides in field? And does the herbicides mention are they not harmful to human health? Oh, just remember to unmute there, Sean.
Yeah, got it. Thank you, Muedanyi. Thank you for the question. Okay, so getting to the pre-emergent herbicides, yes. So pre-emergents are a great tool to use. They do have their limiting factors. Actually, listed in the presentation. So obviously, you need to have direct contact with the soil. Pre-emergents have a bit of a negative effect when it comes to ash and humics. The carbon in the ash actually binds the herbicide, so it actually doesn't get into contact with the soil. So obviously the coleoptile is able to get going, and then the herbicide isn't really effective. So with the full cover pre-plant spray, that's why we would most of the time get guys to spray in the pit. Generally, the pit should be a lot cleaner than anywhere else. There shouldn't be any trash in the pit. Obviously, if there is trash in the pit, you're going to look at air pockets, which is never a good thing. So yes, pre-emergers, there is a big problem when it comes to burning. You don't tend to get very good results if there's a high ash content in the top of or on the surface. Then with PPE and herbicide applications, yes, you should always read the label. Of course, if you're using insecticides or different formulations, some can be more harmful to the skin and the eyes. So yes, PPE is very important. The label is the main key to watching and making sure that you are correctly protected. That video of me with the dribble bars, or the bendy bar, that was just water and white dye. So I was safe from that one, guys. Thank you for the concern.
Okay, thanks, Sean, for that clarity. The next two questions would be for Dean. Dean, the first question says, how does fully mechanized establishment impact growth, survival, and uniformity? And how does it compare to manual operations in this regard? The second question simply asks if are there any other measures in place where companies can ensure their relationship with community stays healthy, even with modernization occurring?
Okay, so the survival, growth, and uniformity is always going to be a bit of a double-edged sword for every forest company. Everything starts with the plant quality, the robustness, and that comes out of our nursery. So there is a massive, one of the things that's been driven home for us This is why I'm very glad that we had Sean's presentation at the beginning, is the absolute is the requirement for plant high quality. The condition of the plug, we are going to be more harsh on plants when they go down planting tubes. You don't have the same amount of attention to being as careful of putting a plant in a hole. You can't. You are pushing production. So plant robustness out of a nursery, absolutely essential going forward for us, going all of our companies. In saying that, the quality of the pits, where we've had good quality pits, which is generally there now, high quality plants and judicious use of water, and we need to, water or hydrogels, our results have been better than our previous manual observations. But the focus has to remain, if you take the focus off of any of those factors, it's going to go back to any other lower standards. The second question around how do we strike this balance between mechanization with needs of the socio-economic environment. In our perspective, we've used, we have our development wing called Modernised Silviculture that is a business opportunity wing that focuses on business opportunities for local communities where we have a footprint, not outside of that area. And we will look at opportunities with them on businesses, developments, helping them with funding, helping them with training. And it's been very successful and it's been going on for many, many years. So that offset has been a very nice balance.
All right, thanks for the responses, Dean. This one I'm going to direct to Nikki. It says, thank you for the presentation. From a contractor's perspective, with the move towards modernization, to which there is quite a bit of semi-mechanized approach on your side, how is it impacting on the employment of your teams? And with upskilling costs, does that include an increase in operators' salaries? And is the financial investment worth the transition? That's from Zimbeli.
Thank you for the question. Obviously, with the introduction of the machines, there will be new skills that the operators will be gaining. So on upskilling, there's a real benefit where someone who was a general worker would end up being an operator or working behind a machine. And we also have got pay rates that are different for mechanized operations and for manual operations. So if you mechanize, someone is going to get a benefit from the different pay rates because they would have upskilled them. On the question around training, they go through training programs annually and refresher courses, and this is very important for them to be upskilled. Thank you.
Okay, thanks. This few will also go back to Sean Biggs. He's still here.
Yes, I'm here.
Sean. Okay, sure. There's two questions here. The question, you say we need to breed for mechanical planting. As we know, breeding is long-term and already have many traits to breed for. Would it not be easier to manage plant quality in the nursery? And then secondly, this is another question from Alson. What could be the disadvantage of paper pod on seedling growth once planted?
Thanks very much, Muedanyi. I appreciate the questions there. Just the first question from Andre on the breeding side. That was really just to raise a question, quite far-fetched, I think, and certainly not the focus short-term. I 100% agree with Andre that I think short-term plant standards from the nursery will be the primary focus, and breeding is really, as he said, a long-term solution. But you know, there could be if mechanized planting really becomes the industry standard, you know, you do see differences between some clones. For example, if you just take one extreme would be Grandis Europhila versus Grandis smithia. You know, there's that Europhila's got a really large leaf size and is more likely to get tangled in the planting tubes. So that's one. You find some clones have more vigorous rooting, and obviously paper pots offers one solution there, but so a vigorous rooter would also help there. So, you know, if it really became the norm in the industry, then that is something that that might be taken into account. But 100%, that's a long-term question. In terms of the second one from Elson, would there be any disadvantage just to paper pots on seedling growth once planted? I would say none from my side that I'm aware of. You know, there could be some cost implications to paper pots over, let's say, the normal inserts. But from a performance point of view out there, as I mentioned earlier, the roots grow straight through the paper, so there's no negative aspect to the performance thereafter. So I only see benefits from a growth point of view out in the field there.
Okay, thanks, Sean. I see the IT people have indicated that we're almost out of time, but maybe perhaps I might just give Professor a question here, which asks, what is the state of soils in Brazil in terms of quality for keeping forestry on growth and also practice in many areas than those covered in indigenous vegetation? So it's just asking the status of soils in Brazil in terms of growth in forestry.
Okay, Muedanyi, the soil quality in Brazil, where we normally plant commercial forests, eucalypt or pine, is normally or generally very poor. Okay, normally we have sandy soils, very low organic matter. However, it's very easy to handle the fertilization or chemical fertilization control. So the soils are flexible and they are not heavy. They don't have a lot of clay that turns the management harder. Okay, so we also try to do the minimum tillage in Brazil to keep the residues on top of the ground, trying to increase our organic matter that is very low, normally under 1% or 1.5%. And we don't use the fire control anymore. That was a practice developed here maybe 30 or 40 years ago. Okay.
All right. Thank you very much for the responses. There is questions that have been listed here, and the IT people have indicated that they will be able to pull out a list so that there can be responses from the different presenters. However, we need to wrap up at the moment. But in terms of closing up, I think there's a number of interesting things that were mentioned from the different presenters since we started. And from the beginning, when Sean Biggs spoke about the importance of paper pots in terms of facilitating mechanized planting. And Jacob also just gave a brief comparison in terms of productivity as well as growth of the different soil preparation techniques. And then Helhad also provided some of the basic introductory steps of using telematics in the process of us going into automation of seedling, planting, fertilizing, irrigating, by being able to identify the exact locations where things are happening, but through planning, executing, as well as reporting. And Sean gave a very practical presentation focusing on the various tools that are available that even small contractors can be able to adopt and use in terms and improve their productivity, as well as some developments in terms of chemical application. Yes, Nikki also provided us very insightful information in terms of a contractor's perspective, wherein There's processes as well as machinery, equipment, people, support from your client that is important in ensuring that the process of modernization can be executed in the proper way. Dean came and gave an overall view on the drivers of modernization from a corporate perspective, that's from Mondi, and also gave a holistic view of the different operations as well as the interventions that Mondi put in place to ensure that there was an alignment between the process of modernization, a selection of equipment and its application, as well as the integration of fire prevention as part of the modernization process. And then lastly, we had Professor Saulo, who also then came and gave us an overview of what is happening in Brazil, some new technologies in terms of planting, as well as irrigation and spraying equipment. So I think that just gives a brief summary of everything that was discussed today. Quite a rich conversation that we had, and presentations were very insightful. So just to end, I just want to thank the people that were involved in the program, our campus principal who did the welcome, but again, a special thank you to all our presenters that took the time to present, prepare these presentations and to come and share this information. It has been a journey. We've had several dry runs, some which went well, some which didn't go well, but thank you very much for persevering through. And I'm glad that today we had a successful day of presentations. I will be also sending you some corporate gifts from the Nelson Mandela University as a token of appreciation for your contribution to this webinar. I would also like to thank all the participants that were involved in the webinar. Thank you for the questions. Thank you for attending and being part of this. This webinar would not have been a success without your involvement and your willingness to listen. And I hope this is an opportunity for you to make connections with people that are involved in the process of silviculture, and more especially the modernization process that can help you learn, and we can be able to build connections with various people. Thank you to Chanel and Tiffany, as well as Angus, who are the people that were making sure that everything runs in terms of the IT and the technical aspects to make sure that the right person was presenting and live. Thank you very much for the efforts and helping us organize this from the very beginning and making sure that the links and everything works. I also want to thank our marketing department, that is Melissa and Monica from the corporate relations side. They were also quite key in ensuring that we are able to get the flyers and advertising this webinar properly. I also want to just say thanks to Kyle and Posisa, who are the students that worked with me in terms of organizing this webinar. Thank you for all your efforts and helping with the organizations. And second last is just to indicate that the presentations, if the presenters are fine with it, we will make available in a PDF format, and as well as the recording of this webinar, we will also make available within reasonable time, and maybe a link will be shared for those that are interested. They can also contact me, Kyle, or Posisa, to just get the link and to be able to view the webinar. And hopefully this, as I indicated at the beginning, is not the last one. We will be able to track this progress in terms of modernization and see where we are going and moving in future. So hopefully next year we can have something similar and then pick up from there. I just want to thank everyone for your involvement and for your participation, and just want to encourage you to remain safe and continue to be involved, and let us be good stewards of our forestry industry. Thank you.